connect to the
Thank you,
one that has guests if you want, and then if you go to the web page and you click on.
All right, welcome everybody. This is the third robotics meeting for the Southern California Robotics Society. My name is Ben Partida. I am the current president, and I am here with my vice president, treasurer, secretary, a bunch of other awesome people. And of course, everybody online, welcome. Thank you for joining us. We have two lectures today. The first one is going to be Alan, who's going to give us an update on his Vision 360 and blinking eyelids for his InMoov robot. Should be fun. After that, Jim, he's going to give us one of his other awesome talks on GPT and
Giving your robot a personality.
Giving your robot a personality. That should be awesome.
The start of one.
All right. Unless anybody has any questions, Alan, take it away.
All right. Yeah. Good morning, everyone. So we're going to switch a couple things around here. All right. So after working for the past year on Pepito and resin printing and right on the cusp of final assembly and programming and bringing that little guy to life, a different project has been dropped into my lap. Some of you may know that I built an InMoov like 8 years ago, and it was super fun. I learned a lot. I cut my teeth on 3D printing, design, assembly, and all that fun stuff. And then, it was shelved. The project was complete, and I moved on. This whole time, I think I can talk about it now. There has been an aspiring producer and small filmmaker who was on the crew for a sizzle reel video shoot for an Amazon series that didn't get funded, that we bumped into, and the InMoov inspired him. Like it gave him a whole new set of ideas on a film to make, and he has been trying to get funding and get it kicked off the ground ever since. So every couple of years we get together with a new script, and this time, actually I think 8 years after that initial sizzle reel shoot, he believes he has the funding, he has a script, and we're tentatively set to film at the end of April. So what that means is I got to take him out of mothballs. So I've got to update him, give him a fresh coat of paint, make him work again, maybe update the controls a little bit, and get him ready for that end of April shoot. So for the next 3 months, my talks are going to be all about the InMoov. This talk this month is going to be more foundational, kind of a deep dive into Fusion 360 and leveraging existing STL files to work on an enhancement or a different design in a way that will fit into someone else's model that they're not giving you the original files. Next month will be final design, assembly, and programming of what will be InMoov eyes that not only move like the originals do, but also can blink and wink. That has been an ask for the guys who are doing the short film. And then between next month and the months after, there will be filming if he gets all of his funding and we do it. So the following month will be kind of a retrospective showing the final design, the controls, and how everything fits together. Back in the day, there was a really beefy computer that was on his backpack. I wanted to go full brains on board. Now, as he's more of a prop, I don't need all of that graphics processing power, and so he's going to be driven by a simple Raspberry Pi that fits nicely into his back. Same control structure. He was built using ROS1, and I'm going to continue in ROS1 only because the teensy microcontrollers that are used to control each of his arms and the head don't support the new microcontroller code that's only in ROS2. So he'll be a ROS1 bot, which is okay. At the end of the day, it still works. ROS is a mitigation framework that gets you from point A to point B, and it works just as well today as it did 8 years ago. So we'll upgrade to the last version of ROS1, and then we'll be good to go. Let me go ahead and share my screen. And screen and share. And so InMoov has been in the office for the past 2 weeks. I haven't had a chance to take him home after the quick video shoot. So in addition to fixing his broken arm, he's going to get a fresh coat of paint across everything that's white. This chest plate, which was originally printed and assembled in multiple pieces, I'm going to combine it with Bondo and epoxy and sanding, so much sanding, and paint to minimize the screw holes and make it one piece, because I think that'll look super cool. And the same thing with the head. It's in about 4 pieces right now. And I didn't bring up the clip, unfortunately, but a few years ago, a band had permission to use an InMoov in one of their music videos. And for a week, they gave the InMoov to someone who does car and body work. And he just cherried out the head. It was totally smooth, one piece, no visible screw holes. And so I kind of want to do the same. So that's something that I'm already working on for the next couple of weeks. And the InMoov has XY eyes. You can control them to look left, right, up, and down, but no eyelids. So no winking and no blinking. Yeah, everything you see is 3D printed. Yeah, lots of sanding. So much sanding.
Spray on Bondo or?
That was actually Putty Bondo, which was a nightmare to work with. I'm going to look for some additional options because it's like sanding cement. Yeah, I think
it's too solid.
Yeah, it was my first time doing something like that, so it was a best effort. But I have high hopes with everything I've learned over the past 8 years. I'll be able to make it smoother. Here's a quick clip of the current state of the InMoov that was taken by Thomas 6 years ago. That demonstrates some simple control rigging. There's an XY control surface that dynamically adjusts the position of the joints in a way that approximates human motion. And when everything fits together, it's pretty convincing. It tells your lizard brain just enough that it's alive and organic to suspend disbelief and to kind of connect with the robot and not the commercial. So that's what we have to work with. And I'll go through a couple of, let's go and pause that. So someone has already designed eyelids. And so this is open source. It's available for download. Unfortunately, it only blinks. There's one motor for both top eyelids and one motor for both bottom eyelids. So while it can blink, it can't wink. But we can take that those parts, we can download them, and we can look and see how he did it, and we can learn something from them. Now, what really makes me believe I can do this well, there's a gentleman on YouTube called Will Cogley. This guy is amazing. I would highly recommend subscribing to him. He just got back into posting some stuff. And he does all kinds of stuff. I'm particularly impressed by his approach to hands and hand design and the intricacies of making everything fit together. He's done some amazing design work. He's a SolidWorks guy, but same difference. But
Jim should see this.
Yeah, Uber Setsig, right?
Uber Setsig, yeah.
He has also done
loves hands. Oh, and design, yeah.
He's also done a lot of work with eyes. He's actually published several different articulated animatronic eye designs at different price points with different levels of complexity. And he even has a tutorial video on how to do realistic resin eyes. I'm like, man, I've just been looking for an excuse to do something like this. And it turns out his simple eye mechanism one motor for each half of each eyelid. So I'm like, okay, so there's an existing design that I can leverage, right? So I've got, actually, I've downloaded all three of them to see how he approached it. And they're all different variations on a theme, right? How you handle the armature, where you put the servos, can it wink or can it blink? But I believe I can use this as a basis to develop something that fits within the envelope, fits within the InMoov skull, and provides this functionality. And it's just a matter of programming it. I think in this version, I'm not going to move forward with camera eyes because I never really used them anyways. So I'm gonna go creepy human eyes. It's a fun thing to try once or twice. And so let me share with you everything that I've done to get to the point where I'm at right now and what my next steps are. Now the InMoov design is open source. It's been available for 8 to 10 years now, and he has released STL files. So not his design files, but an export that's suitable for printing. You guys have probably heard me rant about STL files before. They were great at the time and a very easy way to share design files in a smaller size format, but they are awful if you want to go in and re-engineer them. So we're gonna recap that a little bit in a few minutes. So the thing is like I need to design something for the InMoov without the original design files. How do you do that? And so let me show you my approach. My favorite tool of choice is Fusion 360. Let me go and switch back and share without video sharing, so get a clearer view. And here's where we're going to end up today when everything's done. Is we're going to bring in the STL files from the original robot, and we're going to do draft kind of some doodling to see how the eyes would fit and what they would look like. And then we're going to start retroactively fitting those components in to develop a solution that's based on the mechanism of the simple eye mechanism, but in a way that will attach to the faceplate and then have the right proportions, and then everything fits. So here's where we're gonna end up. Let me show you how we get here. So probably one of the first things that you're going to do when you are importing someone else's STL files is just to create a folder and then do a mass upload of just all of the files in the directory. So you go to his website, you download the zip file with the pictures and the STLs, and then you just upload them all, right? Well, that's the first thing that I did. So as an example, let's look at one of the components together. The eye holder, was that the eye holder generator or the eye holder? Let's see. Okay, we went with the 3-point connector. So it's one of the braces in the design. It was imported in bulk, just like I showed you. And let's take a closer look at this to see if the import was successful. In order to do that, I'm going to do a simple inspect. I want to see what is the distance between this hole and this hole. And Fusion 360 is telling me that the distance between those two holes is 749 millimeters, or 75 centimeters, or almost 1/10 of a meter. That doesn't seem right. And it's actually exactly 10 times the size it's supposed to be, right? And so okay, so that's not right? That's not going to work. And this is a common issue when you do just a bulk upload of a file. It doesn't know what scale to import the STL in. Right. STLs are by their nature a unitless file format, meaning there's coordinates, but there's no descriptor that says every point of measurement is a millimeter or a centimeter, or in ISO units, a meter. And for whatever reason, Fusion 360 always guesses wrong. So I'm going to leave these in here just as a reference so I can see what they look like, but obviously we can't use these for anything. And yeah, you could go in and you could scale it down by 1/10 if you wanted to, but let me show you a better way. And so let me get out of this field here. Now, because I know where I want to end up, because I've done this a bunch of times, I know I want to set up a reference file for the head that's separate from the reference file for the neck and the innards. So I'm going to approach it that way. So I'll set up a reference for the head, I'll set up a reference for the neck mechanism, and then there's a separate reference, a separate file, right, a separate project for the eye mechanism. You could put them all in one if you want to, and it would almost work just fine. But I have a feeling that separating them out is going to make managing this project easier, because at the end of the day, there's only 2 STL files that I'm going to need to modify, and the rest of them is still reference. And then doing this, we can do some fun things like set up an inspect analysis where we can cut through to verify fitment and placement. I think I have 2 of these set up. So, hey, you're just in time. Come on in. Grab a seat. Okay, great. And so by editing that slice, we can go through. This slice is set up specifically based on the center line of the eyeball, but we can go through
like an MRI.
Like an MRI and take slices to verify that what we're designing will actually fit. So, like, if any of you have been around and been tinkering, in days past before all this, it was a matter of measuring, cutting, fitting, very hands-on. And now we can do all of this on the computer. And I'm not saying once you do this, you'll have a perfect design the first time you print it, but you'll get much closer because of the time you've taken to verify.
This is just the inspect feature?
Yeah. So here, let me show you how we got here.
I really needed to, I guess. Well, maybe I did.
Yeah, it's one of those things that like once you know it's there, you'll find uses for it for sure. So under the expect menu, there's a bunch of stuff you can do. The default icon is just to measure the distance between 2 points or 2 features. And the second one that I use a lot is called section analysis. And in section analysis, you start by defining a cut plane. And for me, I always use one of the, on the origin, one of the centerline planes. So the one we were using in the previous example was a vertical plane. Let's choose a horizontal plane. And it just takes away half and leaves half. Now, if you want to get the other half, you can always flip this around to get the top half instead of the bottom half, or just click on flip. And so this provides a horizontal section analysis that does the same thing. I want to look through, and as I'm designing this eye mechanism, you want to make sure that it fits. So this is a good way to put it like so. And so a horizontal slice is very, very important. So I'll probably leave one there. And I'm going to leave it right at the eye level just for next time. The closer you get, the finer the control you have. Right about there. And I'd like to use a second slice and dice or section analysis. And for this one, I'll use a horizontal plane and flip. And you can leave it wherever you want. I'll leave it right there against an eyeball. And super, super handy, especially when you're checking for fitness. Because now I can use the whole thing and get a closer look. I mean, you could always at any time go through and turn off the whole model or turn off one of the slices of the model, but yeah, super, super handy. All right, so let me show you how we get here. We're gonna start by doing, sorry, Jim, did you have a question?
No, I think I see that those section analyses end up in your hierarchy in the under
Oh, yeah,
analysis.
yeah, exactly. And you can turn
So
them all off.
They're just like
You
any
can
other
switch any other feature. Yep. All right, let's go ahead and we'll turn that off for a little bit. All right, so let me show you how we got here. I'm going to create a new design. And so prior to today, I went through and downloaded the STLs from the website already, just to save some time. You don't want to watch me download things from brands. We got better things to do. So starting with the face, we've got a couple of ones. And when you download them, it shows you a picture. And because I've been living in these for the past 10 years, I just happen to know what they are. But when I'm pulling this stuff in, I will start by creating a new design. And this design is going to be where I keep the remove and I keep all of the reference files, the reference geometry for the skull. So I'll just give it a name. Pops up here. And so instead of bringing in the files that I've already uploaded that we know they're at the wrong scale, let's do this from the insert menu. So we'll go to insert, insert mesh. And the eye feature is a great place to start. So let's go ahead and pull that in. And when we pull it in, when you do it this way, it's smart enough to know, oh, your unit type is type millimeter, so it's at the right scale. But we'll check that after the import, right? Measure twice, cut once. And regardless of what it was designed for, you're always going to pull in the files with the wrong orientation based on which program says which direction is up. This is the way that it's printed, flat side down. This is reference geometry to use for designing parts. And so if we flip it a full 90.
So why does it look like the eyes are filled in?
That is a good question. I'll show you in just a moment. That's a good question. No, it's a great question. Now, I also want to kind of center it left to right, and it looks like it is already centered. And the center of the design is just right there. That's fine for now. I'm going to leave it. And so we brought in our STL. I want to make sure it's at the right scale, right? Just our first times being what they are. So I'm just going to click there. There. And 12 centimeters sounds about right? So it's going to be off by either a factor of 10, factor of 100, factor of 1,000, or a factor of 25.4. Right? Okay, so we're good. We're good. Let me go ahead and hit close. Let's preemptively give it a color that approximates what we're going to be using it for when we're done. We'll go to paint, glossy, and white. We'll drag that over. And so now we've got our first component in. Hit save every once in a while. It's pretty good at capturing backups, but you never know. All right, so one piece is in. Let's drag in something else. So again, the insert, and we're not going to do all of them. I'm just going to do 2 or 3 to show you how it all fits together. Low back.
Oh, so one question.
Not that one.
So the insert was the key to getting the right scale, right?
Yeah. So from within the context of a new project or design, if you insert the mesh, it not only gets the units right, because everyone does millimeters now, but you have a choice to change that.
Can you, when you're doing the insert, can you grab like 4 files at once, or does it only let you grab one at once?
Well, the inspect is applied to the entire design.
Oh, no, I meant the insert, sorry.
Oh, you could do more than one at a time, but because we're going to fit them in and manually put them, I'll do them one at a time, just to get them in the right spot. And so that's it from the face. Let's go over to the skull.
This used to be really difficult to like grab a STL and put it in there, but now it's a lot easier. It's just an insert.
Yeah,
That's
yeah.
cool.
And so again, we know the right scale because we measured the first one. Let's go ahead and rearrange this a little bit. This is the piece that the eyeglass fits into. And we're just going to manually approximate its installed location. And we'll usually get within about 100 microns if you're careful about it, meaning it's going to be fine. Right, so, and so you're like, oh, Alan, why aren't you making it fit exactly? Well, this is exactly that, reference geometry, right? Because I want to know when I'm designing something that it's going to fit within the envelope of the skull. And in order to do that, I've got to have pieces kind of in the right spot.
There's no grouping or something.
Now, there's no intrinsic knowledge about how it's supposed to fit. And so you can use design features like the edges to kind of figure out where they're supposed to be at.
There was a way to make them fit.
Well, yeah, there's
automatic.
they like to tell the system where to line it up. So
Right.
yeah, we'll just eyeball it like this. Another thing that I discovered when doing this is that you would think that each of these parts was cut from the same master model, and it doesn't appear so. They don't fit exactly right, which would also explain some of the challenges that I had in assembling it. But you know what? That's okay. It's just something that you pick up when you.
Can I ask something?
Yeah.
Couldn't you assemble it using joints, like when you're putting two things, like you can use one of the screw holes as the two connectors? Instead of like doing like a revolute joint, just do like a, I don't know, some kind of like a slide, but don't even slide it, just use it to align two holes together.
Okay. Yeah. So that's a great question. There are a lot of features in Fusion 360, including the concept of joints in motion, that you can use to describe how two components interact with each other, right? So when you design component A with a hole and B with a hole, you can say, hey, that hole has an axle in it and it can twist or it can slide. The challenge with this geometry is that there's no concept of a circular hole. When you dig into it.
That's right, because it's all one solid, the entire
You
thing
mean
is
mesh.
just one
It's all
mesh.
one
Yeah.
mesh.
Yeah,
You have
yeah,
to
yeah.
convert it, usually convert.
well,
You
and
can.
even if you convert it, it still converts it into a series of facets.
Yeah, it's gonna be.
Yeah.
And
Or-
so there's no way. Now, in some things, if you came in and you made it into a component and you defined an offset plane and drew a circle there,
Yeah, you have to
you
go.
could.
Gotcha.
But yeah, it's just not.
Oh, in other words, you're saying you can't line up based on that thing. It's just
Yeah.
that's just a straight mesh.
Exactly. Yeah, it's just
It's
reference geometry.
You'd
You
have
can
to-
select it. You can select an individual facet, but yeah, you
You
can't
have to
define
make.
joints
You have
or-
to do
Yeah,
your own sketch.
Exactly.
I
Line it
forgot
up
that.
perfectly.
Importing STL.
I've worked on STL imports
Yeah.
because I like to modify things that exist already, and it's a lot of work.
Yeah.
It's a simple algorithm to automatically figure it out, though.
Yeah, well,
Yeah, you would think so,
I
but
would, yeah,
so here, let's take a little.
somebody should do that.
Here, let me show you a little bit. I'm going to go on a little bit of a rant, and I'm not saying I hate STL as a format.
It's
It
just-
got us to where we are
it's
from
for
D for
printing.
makers in 3D, but it's if from a designing, I want to design robot standpoint, it's pretty garbage. So I'm going to create a new design, and I'm going to create a sphere because spheres are beautiful and.
My favorite shape.
And it demonstrates elegantly what the problem is. And then, let's see. Right, so what you're looking at now is mathematic perfection.
Yeah.
It is, no matter how far you zoom in or out, it is always round. Any operations you do against it, mold, deform, cut, slice, it will always be perfectly round to within 64 bits of perfect precision. Amazing. The file size is super small. This parametric modeling describing the relationship between between surfaces is what allows us to do lots of cool stuff in SolidWorks and Fusion and other things. Now, the challenge is because STLs are the lingua franca of the maker's world. It's the only file format that almost all slicers support, meaning you have to export this in a way that you can pull into a slicer for 3D printing or something else, right? So to do that, you save as mesh. And one of my slicers supports 3MF, which is just STL plus color information. So let's select STL. And there are a whole bunch of knobs you can tweak to generate the STL file, which is a series of 3 points and then the surface between. If we do low resolution, and it shows you what the defaults look like down here, and we hit OK. It's supposed to preview that. Hold on. It used to show you when you exported what the resolution would be. Hold on.
The not so round one.
Oh, preview. Sorry. Sorry.
There it is.
All right.
Beautiful.
So as you can see here, it's decomposing our mathematically perfect sphere into a series of actually triangles. It's just defining the points right now. And so the more you zoom into the resulting solid, the more you'll see the surfaces and corners. And that's in low refinement. You can go high refinement. And it gives you finer detail. But at the end of the day, it decomposes our beautiful sphere into hundreds of thousands of triangles that are sphere-like, but no longer behave like a sphere. And so we're working with the result of that export operation back over here. All right, so I want to import one more piece just to show you a trick, and then we'll move on.
Well, I was going to say, you know, STL is kind of like the equivalent of in the old days, a PostScript file. You know, when you printed things in the old days, you had this nice. You started with a nice Word file, and then it prints a special printer format file, and that one is not. It's just for printing. It's similar to and then you couldn't edit it very well.
Yeah.
It's like STL, to my mind, is a print of the original negative, or of the original higher quality file with object-oriented file, and it acts as a little bit of a copyright protection because you can't do as much with that. So, like as an author, if I want to give away, using STL is good because it kind of protects my original.
The binary.
Yeah, it protects my original. Object file in Fusion has all the history and all of the details.
Yeah.
And the person would have to work hard to get it back.
Yeah. But some things like the open source things, like the I mechanism that the guy is publishing, why can't he publish the actual
He could publish
files that you can actually edit?
Like
you know what I mean?
Share,
Instead of just STL.
Fusion 360 has a wonderful sharing community.
You can also share them through Thingiverse.
Yeah, you can share. I haven't really seen.
I never uploaded.
Yeah.
But
I never see them in Thingiverse. It's always STL.
I never see people sharing.
I've seen
the
an
actual,
SVG file or OpenSCAD file.
OpenSCAD is popular.
But in the droid builders community, there's a guy that actually shares the Fusion project, and you can actually edit the whole thing. Yeah. You
Maybe
can
it's
change
also
whatever you want on it.
It's also convenience. A lot of creators, they create something, make the STL, and then assume that's like the norm for a Thingiverse. You just upload your STLs, and nobody thinks about because everybody can print with those.
Yeah, but
anyway, I don't know.
People like us, we want to change everything.
We want to change it.
Yeah. And so there are some other files where they're kind of connected. But Danny, for your question, let's talk about these eyepieces for a minute. So, when Gail designed the face, he designed it with kind of a built-in support
You see the little crack.
to make it easier to print. Now, we don't want this at all, definitely not for reference geometry. And so on the Fusion side, there are a couple of mesh editing tools that they have. It's nowhere near a Mesh Lab or a Mesh Mixer or a Blender in terms of editing individual facets, but there are a few things that we can do to make this easier to use. So on the Mesh menu, let's go ahead and select this STL. And we're going to do what's called direct editing. And we're going to direct edit this body. And the direct editing allows you to delete triangles. That's it. I spent an hour trying to figure out how you could like edit or make changes or move them, but you can just delete them.
At least something.
Yeah. And so I'm in Paint by default, and you'll notice that the brush size covers a fair amount and I need a little bit finer control than that. So let's go and move back the brush size. I'm going to leave back faces selected. And so let's go in and clean this up a little bit. So I'm going to left click and drag.
And you're gonna want that back, is that, or no?
I don't think so. I'm pretty good about setting up support.
Got it. It'll make it.
You don't need a built-in support.
Exactly.
Okay.
Anyway,
So I'm going to paint those and hit delete. Paint these.
That's the back. Oh,
Yep, the back
That's
side
the
of it,
back.
delete.
then you got a little.
Paint those.
Oh, what's that? Oh, that's the edge.
Yep, so I'm just
Those were the
taking.
walls that were there.
You're trimming.
Yeah.
That's cool.
Back through
I never
here.
used this feature. Yeah.
All the perimeters that were on the actual part.
Yeah. So we're just going to remove this, and
Is that like almost like, how many millimeters?
well, the STLs are individual surfaces defined by 3 points,
Okay.
and so
Yeah.
we're just removing those surfaces. Now we're also creating a hole, right, which is going to be a problem. But I'm going to go through first and just take these out. I don't want them.
What happened
And
there?
oh, this is the lip that connects the internal. So we have a hole there.
So that's
We're
a
gonna
hole.
get back to that.
You have to patch that.
And
I wonder what Gail used to originally create this.
Blender. Yeah, he's a Blender guy.
Really?
And the SolidWorks folks approached him with free licensing for SolidWorks in exchange for completing their project. But he had already done the whole thing in Blender, so there was no
To
point.
learn another new product now.
Yeah.
That's too.
That's a lot.
That's another advantage of STL. It's a cross-platform,
Yeah.
whether you are authored in 360, Blender, or other 3D app packages. STL is the common.
Yep. So, all right. So we've got that out, and I'm going to finish direct editing. And now we've got this little switch point. It's like, hey, I checked your solid, or sorry, I didn't check solid. I checked your STL. It's leaky. There's holes in it. So we'll click on repair, and it's like, hey, I'll just fill in the spots. So now it's a solid again.
Did you do? Yeah, you hit auto.
Yeah.
Yeah, repair is one of the best things, best features ever made for
Yeah, for simple fixes, it is able to figure it out. It's an
Simple.
algorithm, right? So if you ask too much of it, it doesn't.
Oh, it
fix
goes
up.
nuts. So.
Yeah.
Can you mirror it and be like, do the same thing on the other side, or will it know that?
That's pretty
Well,
nice.
if you wanted to edit it, you'd have to do the other side separately, which I've already done in the main one. And so you can do simple edits, remove geometry, and in the blinking eye study, that's exactly what I did, just so I could see how everything fit together. And so that's what I did for the head reference. So just all the skull, all the white pieces in the ears. And then I did the same thing for the neck reference. Pulled in all of the files that constitute the neck and the internals as reference geometry, and hit save. And that was the process. Create the design, import menu, bring in the STL, position it to within like 100 microns or so, right? You can get pretty close just by zooming in, and then hitting save. And at the end of those 2 exercises for each piece, that gets you up to here, right? And you've got your analysis, you can slice and dice, you can see where everything fits together and where your room is. So this is a great place to start. The whole exercise took me maybe 20 minutes the first time I did it. It took me longer to download the files than it did to move them around. Because you get into the workflow, right? You download, import, move around. The
How many pieces? Oh, you mean of the eye ones you're talking about? Or
just of the skull and the neck and the base. The challenging pieces were actually the skull pieces up on top.
Oh.
They were positioned flat side down for printing, and they were rotated in 3 dimensions. And I'm just off by like a degree or 2. And so part of me wants to go back and fix that. But the reality of it is I don't need to. I have enough of a reference to know if I'm going to fit or not. So I'm trying really hard not to spend the next 3 hours making them perfect. Yeah, I'm just trying really hard just to leave them. All right, so after that exercise, you have all your reference geometry. Everything's given a color. It's pretty cool to look at. Now let's talk about, to wrap up this morning's talk, let's talk about using existing XML geometry to do something interesting. And to do that, we're not going to pick on any of the pieces of the eye mechanism because you can whip something together and recreate this in like a couple of minutes, like once you're in Fusion. So we're not going to bother with that. The piece that I can't reproduce because I'm not artistic is this eye reference, this guy right here. New design, insert mesh, is this guy right here. I can't reproduce it from scratch. I don't have the artistic skill or the Fusion knowledge to do it. So we're going to have to make do with the reference geometry that we have. And there's a couple of tricks that I've picked up that you can make use of if at some point you decide you want to do articulated eyeballs or adapt someone else's design without recreating the whole thing from scratch. Now, let's go ahead and save this with RSSC demo, use this STL. Right, and then we're going to go back in and we'll do a direct edit just like we did before, just super quick, drag, 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 and delete. Drag, 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 delete, drag, drag. Oh, I got something that I shouldn't have. Did you see that? So just click anywhere else to get rid of it. Remind Ellen to slow down. And so on and so forth. Okay, actually, I think we have to do the whole thing if I want to make it a solid. So we'll just do that again.
Your previous one, huh? I thought you already did.
Oh, you know what? It was in a different model file.
Oh.
I didn't think I had to do it in one spot. So if you'll just give me a second.
No, no problem.
Have fun to watch.
This is like the full speed, Alan.
Yeah. Once you get used to the tool, you're gonna blow through it just like this. It just takes
it's
couple
clicking
of seconds.
It's neat though, it's good to know this stuff.
Yeah, I've never done this level of mod. I use like the simple, what is it called, Tinkercad, and to do Boolean additions, subtractions with like a cube or object. And that works reasonably okay as a brush, but nothing like this detail.
Well, the SCAP.
Yeah, well, that's code, right?
All right, so we've cleared out our one eyeball. So let me share with you a couple of approaches that might come in handy to kind of kick your Fusion 360, use this STL game up a notch. Now I'm going to verify that my geometry imported with the origin towards the center. That's going to come in super handy. Now, when I go through and do a section analysis of this, you'll notice that there's no internal, there's no hash, because it's not a solid. It's a series of vertices and reference geometry that you can't manipulate or do anything to. It's just there for looking, right? Now, I want to change this into a solid so I can do more with it. And it's a very expensive operation. Right now, this format is what's used in video games, and your graphics card can spit out billions of these triangles every second, every day. The process of converting it into a solid does something awful. It takes each of these triangles and it turns it into a Fusion 360 surface. So you're talking about a 10,000 times higher level of processing power, and there's a limit to what items you can convert. We're going to be pushing the limits of Fusion to do it even on this, and there are even more complicated models where let's throw up its hands and lock up and say, sorry, you're on your own, right? But I just so happened by luck, because I've done this already, is that there are the number of surfaces, the number of triangles is low enough that we should be able to convert it. And to do that,
because converting is, I've done, converting on simpler objects is very convenient and pretty reasonable speed. Anything with, that doesn't have organic curves to it, especially.
Yeah. And
how many triangles are we looking at right here? Can you just easily de-res it first?
I don't know. I want to say a couple thousand.
You can kind of see it when you click.
But yeah, I don't have. It's a good question. I don't have a number for you, but I can on how quickly it did convert it. I can say it wasn't a lot. But with one simple thing, we can see that it is now being treated as a solid. It is a solid that has been constructed from several thousand surfaces, but there are a bunch of things that we can do with it now. Now, you'll notice I didn't clear out the other eyelid. That was on purpose. I did this because, let's do another inspect, section analysis. Now, you can see as a result of that, it's a bona fide solid. So it's going to behave more like a traditional solid in your Fusion 360 workflows. There are still a bunch of exceptions though, and I'll try to walk you through as many as I can in the next 7 minutes so that you're better prepared when, if and when you have to get through this circle of hell. All right.
Not fun.
So this part, like many other parts you're going to work with, have a symmetry. The left is exactly the same as the right. Now, I don't know that I need to do this, but because I know there's symmetry and I want to minimize the number of operations, I'm going to cut this in half. Split body, select that body. My splitting tool, I can just use this plane, right? Because when it imported center. And now we've got left side and right side. This left side I want to get rid of. Now, if you hit delete, it'll get rid of everything, which is not what we want. So we're going to remove it from the design space by clicking on remove. And now we have half of a face, which doesn't seem useful, but anything that I do, including changes, adding in brackets and other stuff, I can always do earlier in the timeline. So I'm going to move something out of the way so I can show you. And at any point, I can do a simple mirror. And this is usually your last operation. Mirror this body, this object, and instead of selecting the plane over here, just select the surface. And you can do new body or join. I want this to be one piece, so we'll leave it at join. And we're back at where we were. Like, okay, Alan, that was silly. Why did you even bother if you're back where you were? Again, I have a feeling I need to take advantage of the symmetry, and doing it this way allows me to define features on one side that'll automatically be mirrored as a final operation. So, here, let me get, so you can see the timeline.
This is all assuming that the artistic integrity is kept the original intent wasn't to make
Yeah.
slightly like human, different,
Right?
non-symmetrical.
Yeah,
Surface.
it's a great point. Some of the parts you're working on may not have a symmetry, in which case, you just wouldn't be able to take advantage of this. So, now that I've done this and then hit, save.
Most of us don't have perfect symmetry.
Right, yeah, none of us does, right? That's actually one of the things that your lizard brain will clue into when trying to figure out if you're,
So yeah, it is.
yeah, it's
I wonder
actually-
if he put in a slight asymmetry into the. You'd have to look.
I haven't noticed it, but
You
I
probably
would
didn't,
say it's impossible.
because he's an artist.
Yeah, he does this
Sculptors
for
do
real.
that. He's a sculptor.
Yeah,
so-
exactly. I'm just poking at it with a stick, right? I'm not artistic. I don't have the tools or the temperament.
So
to
if you
do
wanted
this.
to, though, you could just carve out the other eye and
Oh,
stick
yeah.
the whole thing and
Oh,
not.
for sure. You saw the whole thing took like
Yeah.
a minute. I'm just trying to save some time in the future because I have a feeling
You're gonna need this.
the features I'm going to add are symmetrical, so I only want to do it once. And so as we add those features in, we'll just move back a step, right, before the mirror. And then we can work our magic, and then the mirror will mirror it left to right. Now, this early on in the design process, I'm not sure exactly what pieces I'm going to need to keep. I'm not going to change any of the visual parts of it, but I may not be using this center bracket, right? When everything's assembled the way that I want, this whole skull is going to be one piece. And so the entire thing kind of slips on from the top, which means that I might want to set this up so that the eye mechanism itself screws in from the bottom, so that I can get at it from within the skull cap if I want to make changes. So I'm not sure yet. Now, to wrap up our talk for this morning, to show you how to use and abuse STLs in Fusion 360, in order to add geometry to it, this is a solid defined by surfaces. If, for example, I wanted to add a bracket that goes onto the inside, and I'm just going to do a simple thing right here. What I wanted, hold on. Let's get rid of that. I want to define a new sketch based off of this origin surface, and let's just do a quick circle, just for demonstration purposes. Now, I want to extrude this as a solid that goes up to and intersects this surface, right? Now, this is a really silly example, but I'm going to show you a trick that you can use when you're trying to mate over to it. Now, one of the first things you may want to try is just do a simple press pull, and then maybe pull it up through. It's like, oh, I think you want to cut a circle. No, sir, I want to join. So we'll join. But it comes through. And the surface is complicated enough that there's no point where I don't come through, where it intersects enough, right? So then your next instinct is to say, okay, you know what, instead of defining a distance, I want you to go all the way up to this object.
Oh, two
which is something that works on traditional on traditional like parametric modeling, right? So let's do that. And then, yeah, this is what we were doing. Now I'm going to do, I'm sorry. Thank you. Good catch.
Yeah, just
two objects.
So
and
two
then-
object means go up to, in a regular session, this would go
Yeah,
right up to any
yeah.
shape.
Yeah, so let's go ahead and select that object. And hit join. And
Looks like there's a gap.
I
Yeah,
can
there's
see,
two, yeah.
exactly, good eye, that we're still only one object, that it did something. Now let's go back to our section analysis. And let's flip it. And so what it did was it naively, it didn't combine with the object, it naively combined and joined with the surface that I pointed
The
out.
single surface.
Right?
Right.
Okay, so that's not going to work, right? Okay, so now we know. Let's go back to that feature, Yay Parametric Modeling, and edit that feature. And you know what? I've got another idea. Let's go all the way through
All the way through.
and join.
And
And so we're still at one object, right? or one body. Now, after the join, maybe if I select some of the geometry outside and hit delete, I can delete it out, and then the stuff on the other side will stay. All right, well that's not working either. It can't figure it out. So this is another downside of the surfaces. And if you'll permit me to go a few minutes extra, let me show you how you work around this, and then we'll call it. I appreciate your guys' patience. So now let's try this. Let's expose our sketch, and I'm going to show you what ended up working in this situation. Because this is literally how I tried to figure out how to do it. And I'm like, okay, well, if I can't do the whole thing, let's take this guy and let's split the body. That body with this splitting tool. Now let's carve a little hole through it. Okay, well that's not super useful. But we can, now that that's
We made a piece. Carved a piece out.
I did.
Tool. Oh, this.
That's a subtraction.
Yep.
Yeah.
And actually, I want to try something even different. Hold on.
Intersection.
I want to try one more thing. Experiment. So we've got our tube through here. Instead of doing it as a join, I'm just going to try this. I don't know if it's going to work. It's because this is, we're square peg and round holding it. Let's do a new body. So now we have this guy. Oh, sorry, hold on. Let's get rid of that. So now we've got two bodies. Doesn't seem super useful, but I want to try something. I want to
It's kind of weird to have two bodies.
split this body with this body.
It's kind of creepy.
Oh, can you split body with another body instead of a plane?
So let's see. So we've got a bunch of stuff. Let's expose
Wow.
everything.
That looks.
Okay, so we've got our original face. We've got the piece that was cut out as part of the cutting operation. We have a perfectly fit piece from the back and a perfectly fit piece from the front.
Oh, because you split the tube with that chunk.
Yeah. You know what? We could use this, right? So this piece right here, I don't need anymore. I'm going to remove it.
Yeah.
This piece right here, the cut piece, I'm going to remove it. We don't need it anymore. But let's see now if we can take this body and this body and combine them. Now, it's not guaranteed because of the nature of surface bodies, but I really want to give it a shot.
You might get an error. No.
And no error. We've got one body. Let's go ahead and grab our section analysis. That's not what I wanted to do. Inspect section analysis origin. Oh yeah,
Oh,
look at that.
oh.
Perfect. Okay. And so as I move forward with designing this is what I'm probably going to do, right? So oh yeah, my pleasure, Gene. Thank you. So this is the technique that I'm going to use to design a replacement bracket. I want the eye mechanism that I designed to come up from the bottom and bolt. So now I can set up the apex points where I want it to go. And after everything's done on one side, we'll move forward to the mirror operation. And there you have it. All right, so that's everything that I've picked up for me and used so far to leverage existing STLs to extend the design new things from it. I've designed a bunch of stuff for the InMoov over the past couple of years. My hope is that next month I'll have I'm going to do it, so it's not hope, it's going to be a thing. is that
But he's off.
I'll have completed the blinking design, adapting the simple eye.
I thought that was some video YouTube thing you were watching.
Another robot clip.
Oh, okay.
Adapting the simple iMech design in a way that fits nicely within the skull. I might even just end up printing this all out on my resin printer. I think that'll give you some added dimensional accuracy and options that I wouldn't have on a traditional one. I'm going to take a crack at doing the realistic eyes from Will Cogley's resin thing. So if all goes according to plan, next month I'll have all of this done and I'll walk you through the process and programming it. And then the month after that will be a complete walkthrough of the updated InMoov and the control and ROS and stuff like that.
Does this this rig already fit? It's already the right size, or do you have to size it or change things?
Yeah, the Will Cogley eye mechanism that I'm using as a reference is 15% too large, and it has the wrong interocular distance
all right. So it's
to fit within it. So it's not a direct fit, but I can use the mechanism, how it works as a basis to recreate it in a way that fits within the envelope of the skull.
So yeah, you have some work ahead. And is is Will's stuff STL or?
Yep. Yep, and that's what I imported here. Like, you can look at it. You know, here's the complete model.
You could ask. You can ask him. See if he gives you the 360.
Yeah, I could, but what's the fun in that? Yeah, no, I can recreate the whole thing pretty easily. And the thing is, even if you gave me the Fusion 360 files, the design as it fits is the wrong scale. When you scale it down to 85%, the motors are the wrong size, so then you're alter design it anyway. So it's a good idea. And when possible, always just send them an email and ask, right? Because you never know. A lot of them, like, you know, are super proud of their work, and unless they're paranoid about you adopting their design and which is okay as well, right? Yeah, more often than not, they'll provide the files for you, especially if you tell them what you're up to and what you're doing.
I'd just make a 15% larger head.
Right.
That is, I'm gonna go full toddler proportions. Yeah.
Yeah, that's true.
Yeah, for sure. So again, I'm a Fusion guy, so everything I'm showing you is on Fusion. SolidWorks has a lot of similar capabilities. Their mesh conversion, I think, tops out at 10,000 surfaces or 10,000 triangles. I don't know what the upper limit is on the Fusion side, but SolidWorks is 10,000. And yeah, you're just, minimum effort to get the maximum output and to make it work with what you got. So yeah, I'm excited to show you how this progresses. And like I said, knock on wood, nothing else goes wrong. I should be able to have a linking flirty bot in time for next month's meeting.
That's pretty cool.
So we've got a minute while Jim's getting back. So Will Cogley was kind enough, and let me just go ahead and move this over to white so it's easier to see against the dark background. Why am I not seeing it?
So many tools. Wow.
Gray, dark gray, red, yellow. Why am I not seeing white?
No, just a yellow. Sometimes it's hard to find somebody that has both capabilities, the artistic capability and the mechanical capabilities as well. And somebody will use Blender or some other thing to do the artistic part of it, but then you need the mechanical person to do the mechanisms and all that. Hard to find somebody that can do all, and then electronics, so that's a three-part right there. Hard to find somebody that can do all three of these.
Yeah, and okay, so Jim's back. The last trick while Jim's getting set up is that he provides a single STL of all the bodies. You can go in and tell under the mesh menu, you can tell Fusion to try to separate out the items, the items that look like they're separate. And after a couple minutes, it gives you something that you can kind of work with. What's nice about this is that then you can go in and give, different colors to the pieces so that you can kind of get a better look.
What was that? Right, a command you did, mesh and some sort of analysis.
Oh yeah, under the mesh menu, you can select the mesh body, and then under modify, you can tell it to attempt to separate
Wow.
based on meshes that aren't contacting or intersecting each other.
Oh, I
And
see.
it makes it
If
nice.
they're not intersecting.
Exactly. So if you've got things that are touching, it might not do as good of a job.
Yeah, like
but-
the eye hole, you couldn't do that.
Right. But
Yeah.
it's better than nothing.
Yeah, so it could come in handy, let you go through and especially if you're trying to visualize the relationship between components, it makes it a little easier. Again, you can't do anything with the geometry, you can't animate it or create joints, it's just there for reference.
It's just reference.
Yeah, it just makes it,
Isn't there a command that expands, like separates them all at once, a little bit, like splits them? Wasn't there some, I saw someone.
on the animation menu, actually, let's try it really quick. So what you're talking about is over on the animation menu. So you can use this to generate scripted movements to show like assembly, disassembly.
Yeah, like the assembly and like that, yeah.
Auto explode all levels.
Yeah.
Oh, and it's only doing it by components. So yeah,
Yeah.
reference geometry is kind of
Right.
restricted. All right, yeah, it's just taking up a few minutes until you we're getting set up.
I'm ready. Yeah.
All right. All right, thanks everyone. Let me go ahead and
Thank
stop
you,
sharing.
Alan. That was
Thank you.
amazing.
That's really awesome.
Really cool. I eat up some of your time with questions.
Oh, yeah, no, I apologize for going long. It's, you get me started talking. All right, so, you want me to share your camera?
Sure. I have two cameras. Yeah, this one right out here. Give people a second to. I can start my other video, USB live camera. This should be open.
All right, so I'll spotlight that so that even when you're sharing, you'll be the main, there you go.
Yes. Thank you, Alan. It was really, really cool stuff. And I'd like to get back into Fusion for some simpler project probably, but it's really a journey of discovery when you go into that. So my talk today is going to be, it's about giving your robot a persona using GPT chat technology and prompt engineering, both relatively new things to me at least, and to most people. It's been in the news and it's been really gaining a lot of traction across so many disciplines in education. So I guess, yeah, first we can talk a little bit about prompt engineering. And then, so I have, I guess I didn't put a full table of contents, but we'll do prompt engineering, and then we'll show a couple of the GPT running instances I have. One is running locally, cloud local at my home with a 6 billion parameter GPT system, or GPT-J-6B. And then I'm going to be using the OpenAI official ChatGPT, which is on their servers. So this will be and you'll see the difference between a 179 billion parameter model and a 6 billion parameter model. But it's nice to have one yourself that runs in your own system. So what is prompt engineering? Prompt engineering is what we write and we give to a GPT generative transformer, pre-trained transformer, that's what it stands for. And to have the GPT system act as a personality or derive information from a block of text, you need to use prompt engineering. And so there's many resources on the internet. This is one I drew from, and these are the different types of prompts that they were covered. The first one is a task, where you have a certain task that the system is supposed to do, and a desired behavior, and you write that up. And then second one is an FAQ. So you write up an FAQ, and then the chat system is supposed to give you answers to questions. Number 3 is an instruction, how to answer and provide replies only. So this is, you're giving the GPT system a whole bunch of information on what it's supposed to do and how to answer. And this is kind of the one we'll be focusing on, because that's where the chat system, the dialogue one is a chat. I'm sorry. This is supposed to be these aren't. I'm sorry. I screwed up. This is how you in one prompt format. You put the task, the FAQ, the instruction, and then the dialogue example, which is the back and forth. So for any prompt that we're doing, including those I was mentioning, these are the portions of the prompt. So you specify what you want it to do, then Q&A, then how to answer, and then give some examples. So here's an example. Here's an example prompt with those different sections. The task. This is the kind of one I'm interested in, which is a personality prompt, as opposed to other kinds of prompts. And there's several different kinds that are common. So you specify a task. This one is respond to a new friend as a kindly, friendly person. The information about you is given in your personality. If the human asks about something, do your best to help them. And then your personality, my name is Dream, I'm a chatbot. And this example was taken from an article that I read, but this form is very effective. And then the instruction, a human enters a conversation, greet them and tell them who you are or react to their questions. Only give relevant answers. So what's cool about this is you're setting up a instruction just as you would a person in real life to this GPT. And here's the last part, which is the dialogue. Human, hello, how are you? Hi, I am Dream, a chatbot you can always talk to. And then so you see, this is the beginning of the discussion. So you put all this together. This is one file, and that is your prompt. And so to test it, they suggested using, and I kind of like their suggestion, use general questions about the bot's capabilities, direct questions about the bot persona, paraphrase questions of the bot persona, and then requests for help. So this is a test scenario. And here's some questions. And these we'll apply these to my big orange personality. We'll ask these. So general questions: what can you do? Tell me about yourself. About your personality. What are some of your likes and dislikes? How do you perceive your environment and people? This is, you can tell this is sort of to a robot. Questions about personality, rephrase. I love learning. What is your take on it? I have 5 sensors. What are yours like? Again, yeah, it's talking to a robot now. It's not. And then asking for help. How can I detect intruders in my home? How can I find my missing remote? So these are some questions, and some of these I'm testing some things that are already in the personality, in the prompt. And here's some, I'll publish this, I'll post this deck to the to our group, Google group. But there's some links in here how to do basic prompt engineering, evaluating models with simple prompt types. So there's a whole article here about what the models are available out there on the internet, and ones you can download and actually run, and then how well they do with these different prompts. So there's like a test of all these different ones with different, and the test ones they use are a QA answering system about SpaceX, the company, a pizza order assistant, and then a chatbot with Persona. That's of course the one I'm very interested in working with. And yeah, there's a bunch of stuff here. Yeah, you can the very simplest type of prompt you can do is, they cover it here. Like here's really basic. The sky is, and then output blue. The sky is blue on a clear day. On a cloudy day, the sky is gray or white. So that's extremely simple. And then here's another case. The sky is so beautiful today. You're going to get different answers because of the randomness that's built into the system. And yeah, again, we're going to leverage on the QA format, QA, or in my case, instead of QA, it's human robot. Human says something, robot says something. And you can do question, answer, question, answer. So this is a good article to give you some basic concepts of how prompting works. And here's that part I mentioned, instruction. You give it context and input data. So these are, yeah, this is good. Good way to get started. Yeah, here's a simple instructional one. Translate the text to Spanish. Then it does what you ask it. So, but yeah, I'll let you read that. That's a good article. And so any questions on basic prompt engineering? Well, now I can show you. I'll show you what the prompt for orange. Might as well show you that. So let's make this big enough. Hopefully you can read that. So this is the oranges prompt for my robot. I ask him you see these common sections that I mentioned about before: task, personality, and then instruction, and then dialogue at the bottom. So the task is respond to a new friend as a kind, friendly robot. I remind him that all his information is in his personality section. And I say, when possible, use facts from personality when answering questions. But I give him a little leeway to be creative when he's giving his opinion. But yeah, this is some basic information about and a little bit of personality. I'm still building this. This is a work in progress, kind of the beginning really. But I'm giving him some likes and dislikes. I'm explaining a lot of his. Most of this is explaining what he can do and what he's made up of, his parts. And then instruction is the same as you've seen before. A human enters a conversation, greet them and tell you who you are. Controlled. And so here's some example. Hello, what are you? I am Orange, a personal assistant robot in training. What can you do? You can give me a command that, for example, move me to another room, etc., etc. Yes. Trying to see how I can. Oh, I see. There's the rest of it.
Jim, do you have a question online?
Question. Okay. How do you deal with going over the max input token limit when I can't even read it? There's something.
Well, when a conversation grows larger.
Jump to first one. Yeah. Well, I don't currently. It just at this point. Well, what would happen is my plan is essentially the full description will stay, the prompt will stay there, and the oldest part of the conversation will scroll off. And so it will only remember, it'll remember itself, all of its own, all the stuff you're seeing here will never go away. But the conversation, human, robot, this portion it will be kind of scrolling. Now, I'm going to show you two different things. The full ChatGPT from OpenAI, it has 4,000 tokens. So that's a good chunk, and that will last a while. But if you ask it something about early in the conversation that at the end, after a half hour of talking, it won't remember. And the other one I have is the one I have cloud local is a 2,000 token, so that's 2K, so it's a little less. But that's the current technology, and that's the current limitations. And if there's anybody who has suggestions, please let me know. But I haven't really. This is kind of the beginning of this, and that's my idea, is just to let it scroll off at this point. All right, so let me go back to. So here, using GPT on your robot, what's really nice is there are Python APIs that make it relatively easy, pretty much very easy to use for a fairly, even not a very advanced Python programmer. And so I'll show you a little bit of that. And so to start with, we'll go into how I set up GPT-J-6B running locally. Well, by local, I mean cloud local. So it's running on, my machine at home, which has a very powerful video card. Hold on a sec. It has an NVIDIA 3090, and with 24 gigabytes of memory. So this one requires, the GPT-J-6B is an open source system, open source model that will take about 12 gigabytes of video memory. And the only reason it can do that, it's 6 billion parameters, 2,048 tokens. It can fit only because you can switch it to use 16-bit floats, because normally this would take 48 gigabytes, for a fully trainable or retrainable system. So, and it would take 24 in regular float, but with 16-bit float, you can get it down to fit within your hardware, or most top hardware has 24 gigs. And it won't perform like ChatGPT, but it runs in my hardware, which is there's advantages to that. We'll get to that in a sec. So here, this is some links here for the GPT-J-6B on Hugging Face. So Hugging Face is your go-to place for all sorts of neural network models, and this is their home. All the open source ones are available here, and there's lots of instruction and description of how they work, and you can download them. And this other one is the documentation for GPT. So those are good links to go into. Oh yeah, I actually put it here that this is Orange's persona that you just saw. So this is a work in progress, and you will see how well Orange can answer some questions that we give it. In fact, that we'll give it the ones, we'll leave this up here, and we'll give him those questions. But yeah, the website Hugging Face, with those two links, both this one is sort of the model card and the files you can download, and then there's the documentation with that other link. This one here has an overview tells you everything about how the GPT-J works, and then here's the info on how to set it up for a computer that with the video card that most people can afford, or I mean that as opposed to many thousands of dollar ones, and then little bits and pieces of your Python in order to how to work it. So those are some good resources. It's okay. So now we can go into show you how I'm going to start it up in. So now I'm logged in here. This is my system at home, the server computer, and what we're going to do is we're going to launch the server. And now what I've done, in order for this to work from across the internet, I've created a simple socket server. And so this, here, this is the right one. So in order for, what happens is my robot here, Orange, is going to accept your voice, convert that into text, send the text up to this chatbot on a server, then the chatbot sends a reply text, and then Orange speaks the text. So you've got, and the speech recognition and the speech synthesis are local. Those are on board Orange, on its single board computer. And the chatbot's in the cloud. So how do you get the text to the chatbot and the text back from the chatbot, the query and the response? So to do that, I looked up, I knew the word socket. Socket is a simple endpoint, the endpoint of a communication between two items on the internet, say. And so a socket lets you open a connection, send data, and both ways. And so that's what this is. So I made it, and it's very easy to use from Python. All you gotta have is a port number and an IP address, and then you can use this socket. And the socket's been around since the beginning of Unix, which is from the 70s, really. Sockets along, and so I won't go into detail here, but once you create a server side of the socket has two ends, the client side and the server side. The server side is where this GPT-J-6B exists, and the client side is where is my robot in this case. So this code here will start up a chatbot and wait for connections from the clients. So to do that here, we can run that exact program by typing Python orange chatbot socket and now watch over here in this in the GPU. You'll notice, okay, as it's setting up, now the GPU memory was 0, just went up to almost half of the 24 gigabytes. That's the model loaded into memory. Now this is waiting for connections. And so we're ready. I guess I need to turn on orange here. Or turn on the speaker. Make this pretty loud. We'll see. So orange is on the other side of that. So now we'll go over, this is orange over here. So this is the orange robot. And now I'm going to start him up. Okay. Now what we'll do is start up orange. And orange, so in Orange's code, there is a client side, and that client side is fairly small. Oh, that's going on to the. Now let me switch the audio port so that it's going to talk out loud here in this room so that everybody can hear it. And the microphone should pick it up, I would hope. So we'll say play on remote computer. Audio becomes an issue, and where do you send the audio and all that? So now the audio from Orange is here. Let me just start up this. Probably don't need to. Okay, so now we're going to launch Orange, and we also show you a little bit of what that the chatbot client looks like.
I'm starting up.
Not to spend too much time on code, but
I could not connect to SlamTech. Movement is disabled.
So we're not moving the robot, so we don't need to have him do that.
It's good because it always makes me nervous.
Oh, when he's up
You
on
know,
the,
yeah, no dig against you, but just robots in general.
yeah, his
Hello, my name is Orange. Pleased to be at your service.
yeah, he's not going to move anywhere because that's just not. This is what that client code looks like briefly. Chatbot socket client. It has the connect. Well, here's the use of it at the bottom here. All we have to do is we say chatbot socket connect. I've got a little class up there that handles, a few of the details. And then we connect to the chatbot, give it its IP address, and then we get back, then we start calling functions, get response. This is an initial response, and then the main sort of loop is send message, what the person said, and then get response back. And then when you say goodbye, it quits, basically. And there's a few other convenient things here, like show the log. Yeah.
So I was just gonna ask, for getting into like robotics and programming and all of that, what's just like a relatively well-rounded code to first learn, like coding language?
Oh man, that's a
Oh,
tough one.
yeah, there's a lot of options.
Yeah.
So like if
Your
you just
robot.
want, if you just want to
Python-
make like a little robot has a little arm or something.
There's
Arduino.
Arduino.
Or Raspberry
Yeah.
Pi.
Yeah, Arduino is good
Oh.
still. C-like language or Python are both really good choices.
That's right.
There's
So
also
there's also some hardware called microbit.
Microbit with
It's actually
TypeScript.
yeah.
TypeScript
Microbit allows you
or Python.
to do a graphical interface that you drag and drop blocks, and then it has an option where you can switch the view, and it'll show you the code behind those blocks. So that way, by creating your logical
Oh, I think I've
blocks,
seen that. Isn't it like
Yeah.
the little like pathway you connect those blocks?
yes,
Yeah, if you're
yes.
not a programmer yet, as far as typing code like this, then the block system is really a good entry level, and I've used that. I actually enjoyed it, and then you could even on one of them you could flip a button and it would show you the equivalent code in
Yeah.
writing after you
Yeah.
made the blocks.
I could like use that to, like as reference to learn like my own code.
You can
Yeah.
learn, yeah, and I once with the microbit.
Yeah, once you drop like a block or something, create some simple
MS.
logic, you can go look at the code and see, oh, okay, so this is what does this, and then you can copy that code and do something else with it,
Right.
and you can create a whole bunch of other more complicated things that you can do.
Yeah,
with
this
the block.
Microsoft Make code
Okay.
is the one I really liked, and it worked quite well.
Oh yeah, make code does the same.
Yeah, make code from the microbit.
So like to get that one to like drive, what did you use for that?
Well, this one's I mean, this has many levels, but it's got like mostly that's C code though. This is an advanced system, and it has C code running on a microcontroller, and then it's got a Windows system running Python. So those are the two things working there. But this is this was not my first thing.
Yeah,
It took a long time to do that.
We're kind of off topic, but I'll talk to you.
Yeah.
And can give
But
you-
yeah, I highly recommend MakeCode. You go in here and it shows you how to do blocky code. See, shows you how to piece together these blocks. And anyway, but yeah, we'll talk afterwards, I guess. So we don't.
During lunch, we're usually here and just free discussion.
But yeah, this is an important thing. I mean, this is an advanced topic I'm covering today, and we definitely want to cover simpler things as well, or give information. So okay, now Orange is running, and you saw that code. So now what I have two commands in Orange. One to open the chat cloud local, and one to use the GPT one. So we're going to open the chat cloud. Hey Orange, open chat cloud.
In chat mode, I can answer questions about myself. Say goodbye to end the chat. What can I answer for you today?
What can you do?
You don't have to give it the prompt, the keyword.
I can execute a variety of commands such as navigating to a specific location, detecting and recognizing objects, finding an object in the room, taking your picture, and even following you around the house.
Tell me about yourself.
Sure. My name is Orange, and I am a personal assistant robot in training. I am outfitted with many sensors, including a LiDAR and AI cameras that help me navigate rooms, recognize faces and objects, and avoid obstacles.
What are some of your likes and dislikes?
As a robot, I do not have likes or dislikes in the traditional sense since I do not have emotions. However, I do enjoy learning new skills and being able to accomplish new tasks.
How do you perceive your environment and people?
As a robot, I perceive my environment through my sensors such as my LiDAR for mapping rooms and avoiding obstacles, my Luxness OP cameras for stereo vision and object detection, bump sensors, and wave radar to detect moving people even behind.
I love learning. What is your take on it?
As a robot, I am programmed to love learning and acquiring new skills. In fact, one of my primary goals is to learn and grow my abilities.
I have 5 senses. What are yours like?
As a robot, my sensors include a LiDAR for mapping rooms, navigating, and avoiding obstacles. I also have 2 AI RGB depth cameras, bump sensors, and an wave radar.
Can I add detect intruders in my home?
As a personal assistant robot, I can help perceive if there is a moving person behind a door or wall using my wave radar that can detect motion.
How can I find my missing remote?
To detect intruders in your home, you can use security devices such as motion sensors or cameras. As a personal assistant robot, I have 2 Luxness AI RGB depth cameras that can detect people and objects in a room.
How can I find my missing remote?
I can help you find your missing remote if it has a distinct shape or color. I can also identify it using my object detection system if I am introduced to it in advance.
Okay, goodbye.
Will it handle general conversation like
Goodbye.
ChatGPT? Or
Have a great day.
only these
Don't
pre-canned
hesitate to come back
topics?
if you want to chat more in the future. Chat has ended.
It's doing, I mean, it's also ad-libbing where it doesn't know. I've tried to keep it within the context of that, its prompt, but, it's using the full engine of ChatGPT. So if I give it more creativity in the prompt, it will do that. It'll take that. But I don't want it to go off on, things that aren't real. All that stuff you heard is real, and I can do every one of those things. And it's phrased in a completely way I did not write it. So,
sorry, but it had like an radar.
Yeah, millimeter wave. It didn't pronounce that right, but
it said like it can see.
Yeah, that's this one right
Can
here.
I see through walls?
This one can see
Tape
through
walls, yeah.
So
non-metallic. Non-metallic. Well, did it say if it said walls? It can see through doors and simple walls.
So like if I
A
asked
wood
like,
wall maybe.
my dad's sitting out there, if
Yeah.
I can see him, would it be like I can detect somebody outside?
Yeah, if they're moving,
Oh, if they're
especially
moving.
if they're moving, or I'm going to get a better one that can detect breathing or any just the chest movement or
They
just
can
like doing
do that.
this is enough.
Through a wall.
I don't know, through a a small barrier, maybe not this wall.
Wow, that's kind of scary. It just sounds like the Terminator, You look at the wall as like.
It's using radar doesn't go through any metal, so or any thick walls, but so it's kind of that's a little bit parsing the words there, but it can go through some barriers. I've done it through a table, a wood table of an inch thick wood. And okay, I made a mistake. That was ChatGPT you just heard. That was the good one. Maybe the good one is better to start out with. When I said cloud, the cloud one is ChatGPT. So I was going to show you that code.
There's some questions online, Jim.
Questions. So that was actually using ChatGPT, not the one on my server. So we'll do that one now. I was able to get ChatGPT-J to run an 8-bit. Oh, excellent. That might help me too if I need to run more things on my video card, like language stuff, language processing. Curious, have you any ideas or thoughts on how to integrate other senses with the AI? Describe to me what you see in front of you. That's a really good idea. And this is the beginning for me as far as the GPT on the robot. So what you're talking about is something I really do want to get into. First, really, I want to be able to give a command like to the robot and use GPT to break it down into steps that the robot can do. And so through a prompt, you can have a list of things the robot can do, like robot can take a object from a person on its tray to another person in another room, and then a robot can find a remote by driving forward and scanning its camera. And so then you'd ask it, find the remote and deliver it to so-and-so. And then ChatGPT would say, okay, here are the steps. And those steps would then go into real commands into the robot. And but describing what you're seeing is exact. In fact, that's an exact thought I had at one point for, say, running but that would require, in a simple case, that I could just have it describe what it's seeing through its AI camera, the bounding boxes for running the tiny YOLO V4. So it would say, I see a remote and I see a person. That's doable. So yeah, that's a great question, and gives me an idea for a future talk. So let's open the other one here. Remember now. Hey, Orange, open chat local.
In chat mode, I can answer questions about myself. Say goodbye to end the chat. What can I answer for you today?
What can you do?
I got nothing on that.
What kinds of behaviors can you do?
I got nothing on that.
Let's check to see if there's some problem here.
I got nothing on that.
Goodbye.
That was the lock guy.
I got nothing on that. Chat has ended.
Okay, there's a slight problem with my. Let's see if the server is. I didn't break something. Okay. Oh. Yeah, it is running, but robot is not responding. I've had this problem happen, and I have to kind of restart. I actually have a way to restart it. You can ask it to restart. So since I'm here, I might as well just do it manually. Yeah, sometimes the server of the GPT-J-6B does not work, and you just run it again and it seems to do better. Let's see.
When in doubt, reboot.
I like
Hey,
it.
Orange, open chat local.
In chat mode, I can answer questions about myself. Say goodbye to end the chat. What can I answer for you today?
What can you do?
I got nothing on that.
Oh. It's the first one that does it. It has the second one is fine. I can make you a
So the chat local also uses your home server?
That's using home. The other one was, the previous one was ChatGPT from OpenAI. That's what that whole demo before was ChatGPT.
I got nothing on that.
This one is my local one. This is the only local one. It's, yeah, I don't understand what's going on here. Why is it doing that?
Sorry, I could not do what you wanted.
Oh, maybe, the system seems to be sensitive to,
Sorry, I could not do what you wanted.
Did it work at home, Jim?
I'm not answering. Goodbye.
I'm sorry, I can't continue the chat at the moment.
That's because at the time it disconnected. So let's see. First of all, let's just stop this. I think there might be a problem with the having a something in the chat, in the prompt that this one doesn't like a quote. Do I have any quotes? No, it was working. It's just the first one isn't working. The first response, for some reason, why? I can also just do it locally here to see. Use a simple interface so you can see the text. Do the whole process with Orange and everything. So here I have also a client. Chatbot client. So way to code all this is you do it in stages and create text only clients and that sort of thing. So there's many levels of debugging. This is the all on the server now, and you can see here this is my text interface, and now I can just type those questions. What do you do? And you see on the other side, you receive the connection, and now he's processing what to do. And okay, now it's working. I can help with your chores. See, it'll only take this first one, not it cuts off the GPT system will try to predict the human and the robot. And what you do is you just cut it off after the first robot, and you only put this in the log. So, so the rest of this is like, oh, okay, the GPT system is just saying, okay, it looks like this is a pattern, human, robot, so I'm just gonna fill it out and keep doing it. And so he's gonna make up conversation between you and the robot. Kind of funny. So this seems to be working, so I'll do is stop this one. You can tell, yeah, it's robot by. Okay, so now it's waiting for connection. So let's go back and see if orange will work now. And if anybody has ideas on why sometimes it just doesn't.
There's a suggestion online. It says could it be the new line you have at the bottom of your prompt?
Oh, new line at the bottom. No, I think I needed that, but I don't know. I'll try. Because sometimes it works, sometimes it doesn't. So why would that? It's non-deterministic. I don't know. I'll try anything on, but okay. Hey, Orange. Open chat local. By the way, you can see I'm using the wake word detector.
In chat mode, I can answer questions about myself. Say goodbye to end the chat. What can I answer for you today?
Okay, we did the first question, so second one. Tell me about yourself.
Let me first tell you what I am. I was built and programmed in 2020 by Jim D'Annunzio from mostly off-the-shelf components.
What are some of your likes and dislikes?
I like new things.
Could you elaborate on that?
I like learning new skills and being able to accomplish new tasks.
How do you perceive your environment and people?
I have a LiDAR for mapping rooms, navigating, and avoiding obstacles.
I love learning. What is your take on it?
I love learning new skills and being able to accomplish new tasks. I am a testbed for new technology. I can demonstrate some household skills, but am still learning.
I have 5 senses. What are yours like?
I have 2 AI RGB depth cameras, both called the Lux and ISOP. The lower one is for obstacle avoidance only. The upper one is for stereo vision and object detection.
How can I detect intruders in my home?
I got nothing on that.
Let's see what.
I got nothing on that.
How can I find my missing remote?
I got nothing on that.
All right. What are some of your pet peeves?
I got nothing on that.
All right, goodbye.
I got nothing on that. Chat has ended.
There you have, that's the GPT-J-6B is decidedly not as good, but it did pretty well for a good chunk of that. And yeah, I didn't get into anything funny. I should have, because I have some sort of funny personality things. I actually try to make you laugh at least once because it can be funny. Anyway, you had a question?
I forgot what it was, but this model is a pre-trained model based on just some random database that it scoured from the web.
Yeah, well, GPT-J6B is trained off the pile. It's many hundreds of gigabytes of internet stuff and medical journals and Reddit and all sorts of stuff.
So when it says I've got nothing on that, does it mean that?
Well, I just wrote that. That's my writing. When for some reason the robot is not responding, it's putting in blanks here.
Okay, so it's just not running the model. It's not that it doesn't have anything in its model.
It's running it, but it's coming up empty. So I just put in the words, I got nothing, because I didn't want it to say nothing, because then you can't tell what's going on. So as you can see here, like, yeah, most of the time it comes up with something, right?
Okay.
See, I love learning, blah, blah, blah. But yeah, and so I wanted to do is, get it to, say something. Well, the other model is more sophisticated. Let's put it that way. So let's do one more example on that. Hey, Orange, open chat cloud.
In chat mode, I can answer questions about myself. Say goodbye to end the chat. What can I answer for you today?
What makes you bored?
Hi, can I get 2 burritos?
I can get bored when I am repeatedly asked to do the same task over and over again, like going to the kitchen or delivering things to a specific person. But I am always eager to learn and do new things to avoid getting bored.
That part is in my, part of that's in my prompt. Oops, I shouldn't be talking about.
Yeah, I'm curious, ask it something that's not in it.
Yeah, but I am. Well, some of those things were, but yeah, actually, let's open it up, because since I'm the programmer, I don't test as well as.
I'm sorry, I didn't understand your question.
Who wants to give it?
What's your favorite color?
Sorry, I'm not sure I understand your question.
What's your favorite color?
As a robot, I do not have personal preferences, including a favorite color.
What's more dangerous, sharks or coconuts?
As a robot, I do not have favorite colors, nor do I have the capability to have preferences or opinions. However, regarding your question, statistically speaking, coconuts are responsible for more deaths per year than sharks.
Are you serious?
They fall on your head.
I apologize, I am not sure what you are asking.
In your opinion, what's it going to take to combine classical and quantum mechanics with physics?
As a robot, I do not have opinions. However, the field of quantum mechanics and classical mechanics is an area of active research and study for physicists around the world.
How many people are in the room?
I'm sorry, but I cannot answer that question since I am not physically present in the room with you. As a robot, I can only sense and understand things in my immediate surroundings.
That's not hooked up yet. Good question.
Ask it, how will it be in 30 years?
In my opinion, combining classical and quantum mechanics to fully understand physics would require advancements in technology, research, and collaboration among scientists from different fields such as physics, mathematics, and computer science. I apologize, I did not understand your previous messages.
What's your favorite Pokemon?
As a robot, I don't have favorites like humans do. However, my sensors can identify different Pokemons if they are in my field of view.
Statistically speaking, what is the best government that has been implemented?
Oh, very cool.
I'm sorry, but I don't understand your question.
This HR moment brought to you by New Guy.
I heard something different there.
I'm sorry, I didn't understand your previous messages.
Statistically speaking, what is the best government that has been implemented?
In statistics, it is important to gather data in a representative manner and then to use that data to make inference or predictions about a population.
Statistically speaking, what is the best government that has been implemented?
As an AI language model, I cannot have opinions or biases, but according to various surveys and reports, some of the most effective and popular governments in the world are those in the Nordic countries like Norway, Finland, and Denmark.
Goodbye.
Goodbye.
Now,
Have a
we
great
should
day.
try that on my model.
Chat has
I
ended.
mean, not my model, but the local model, because I don't have the guardrails on it. So they have all these guardrails for political correctness. I don't know if mine will have a dumber answer, but it might have a more.
I was like looking for this robot to just look through like every report out there and just be like, this one has been the best.
Well, it gave you some.
It gave me
information
something.
there. Those
yeah.
Nordic countries, that's a legitimate answer.
That is.
Although my experience with ChatGPT is that it lies to you about 40% of the time. When you ask it for specific information.
Oh yeah, the truthiness. Yeah, it sounds convincing though.
Well, that's why
that's why you need to.
That's why I really compartmentalize it with my prompt, saying you will not say anything false, or whatever outside of this text, even.
Or maybe
False
even just getting your
Well,
own
outside
AI
of this
to
text that I'm
analyze
giving it.
statistics and analyze data.
Yeah, but again, it's biased like it is from all the human output there is. I'm sorry. What? Go ahead again.
Oh, I was saying that like you could just get your own AI to go ahead and scour and find all the statistics and data and all that stuff and just put it in there, and it can analyze it and just find pros and cons from every single one and just find the best one.
That's what ChatGPT did.
Yeah, but
I mean, I'm cutting it off. I'm not allowing.
Yes and no.
This is only a 50 word or 50 token answer. I cut it off. I won't let it, for purposes of convenience here.
And this is a great line of questioning and talk about it. At its base, the large language models that are in play today, including ChatGPT and GPT-J, what they do is based on the previous numbers of words in a prompt, it guesses the next word. And so depending on the size of the model and how many parameters, that the larger the model, the more types of patterns that it can infer. Because internally, like you're getting an entire paragraph, but internally it's like, give me the next word, give me the next word. That's exactly how it works. And once you come to terms, like come to peace with what it's doing, its output makes so much more sense because its output is only as smart as the pattern it's able to infer from its input, the 100 gigabytes.
I mean, it's a
in the
lot
file.
of pattern out there.
Mm-hmm.
Yeah. And so the bigger the model, the better. GPT-3 and 3.5 Turbo, the ChatGPT, can infer so much more than like the 7 billion parameter GPT-J. But at the end of the day, it's like, oh, I think this word will come next. And so that explains the truthiness of the output. Because its output, generally speaking, will sound logical and informed and well thought out. But at the end of the day, it doesn't really know truth or falsehood or opinion.
No, it's based on statistics of its input.
It's a statistically relevant word based on the previous word.
So if you curated its input as a developer somehow, and to only these sets of known facts, and did a huge effort to do that, then you wouldn't get anything else.
Yeah.
But nobody's willing to put that effort in because they're taking the pile, they're taking many, many gigabytes of info, uncurated, and just throwing it in because it would take how many years to curate that?
Well, and they do a little bit of culling to take
They do
out,
some of it,
right?
huh?
But at the end of the day, it's still identifying patterns. So based on the prompt or the preface or the context that you kick off a conversation, you can get the same large language model to be pro-democratic, pro-communist, pro-life, and anything you want.
You can lead it.
Reason. You can lead it based on identifying the patterns inherent. In the
Okay,
conversation.
that's right. I'm trying to make a personality here from a text saying you are a Democrat, you are a do not believe in fascism, whatever. This whole thing, then the model will adhere because it's statistically trying to complete what the prompt, and I gave it that.
Yeah.
So you can harness it. I don't really care for random, like everything, Barbie doll, pull the string, just say something. No, I need something that I'm working on modeling this and boxing it to a particular personality. And that's what Thomas Messerschmitt's doing too.
Yeah, and so by giving it the prompt and giving it every opportunity to identify those patterns, you're kind of steering it, but there's still no guarantees.
No guarantees.
It can still go off the rails, but more often than not with careful prompt planning and a large language model, you can get some really impressive results.
Yeah, that's prompt engineering.
Including, building in a piece that uses object recognition, and then those object recognition outputs are integrated into the prompt.
Yeah,
it can then make use of it. So yeah, it's
gonna
cool
take me
things to
time.
slice bread, but
Right, like
it's so much fun.
The thing I've seen is there's this YouTube channel, Corridor, and they're really cool.
Yeah.
And they had
YouTube.
this AI, and they basically gave it a ton of source information of this one anime, like this old anime. And then it learned this style of animation, like it learned it from all the bricks, from all like the flowers, from all the characters.
Yeah.
And then they got a ton of photos of the guys in costume and fed that to the AI along with the stuff, and then made like an AI generated him in that anime, and it was to the style of that. And then they took a ton of those images and compiled that all, and they had all this data, and then they filmed them, and then all of a sudden now they have an animated scene from just video photography.
Yeah, Corridor Crew, Corridor Digital.
So I feel like
they're a VFX house.
that's what I feel like is what you're saying with your personality. You want to box it in. They like boxed it in by like making it only his character, only him wearing this suit, only him. So that way it was more fine tuned.
That was a visual one. Like
That was
Dolly,
a visual,
Dolly
but I
too.
can definitely see that it could still be applied to text based.
Of course, either way.
Same idea.
I'll have to check that out. Corridor Crew.
Oh, they're a good bunch. They do. It's primarily VFX, but they dip their toes in topical things like.
Yeah, they've done AI stuff.
But they're using AI in this case.
Yeah, and then they take this AI like generated stuff and then deflicker it, and then boom, they have like animated.
Oh,
like they have a whole animated piece just from filming it like this.
Oh, just from filming. From what was
from like a camera, from just a camera, and then the AI went ahead and had all this data to make that camera footage into animated.
Oh, I see.
And so they made the guys into characters.
These were people. This was filming people. And
Yeah, they were just filming people, and then it turned them into the.
Wow, that's cool.
Using AI.
Can we go into lunch?
Yeah, you want to ask it that? Let's just do one more thing with ask that same question. Hold on. Hey Orange, open chat local. Hey Orange, open chat local.
In chat mode, I can answer questions about myself. Say goodbye to end the chat. What can I answer for you today?
Statistically speaking, what is the best government that has been implemented?
I got nothing on that.
Oh, no, okay.
Okay, all right. Let's see, is that...
Jim, real quick.
I got nothing on that.
What are you using for text to speech?
Hold on a second.
I got nothing on that.
Goodbye.
I got nothing on that. Chat ended. Using the speech is using Windows speech old school. Using I think David or I had to hack a little bit to get one of the better ways. You can even buy them. But this is the Windows called SSC and text speech comes free and for speech recognition I use Boss. I've seen the Boss in the output here, but BOSK Boss is the policy-based speech recognizer, and that's really it's really good. And it runs it has a 50 or 50 megabyte model version that can run on Raspberry Pis and single board computers. Here, that's the Boss API. That answers your question. Okay, here we are. Yeah, so speech to text is speech to text is Sappy in Windows. So yeah, that's what I mean. That doesn't work on Linux or anything. I'm just using a local Windows thing. What another question? Yeah, I'll check that new line thing. It seems to work sometimes and not another. No, that yes, thank you. That concludes my talk. Appreciate your going over. It's 12:24. Just go back 1:15-ish. It's about 30 minutes for lunch. I'll let you guys hear if there's anything local. Usually walk to it.
Yeah, so welcome back. We are now in the show and tell portion of our meeting. And according to my list, Alan, you are up first. If anybody else online or here in person would like to do a show and tell and get on the list, let me know. I will add you. Alan, you're first.
All right, let me go ahead and share my screen again. So there's two things I want to talk about. The first one is actually for our newest member, Lance. And you have a very, very good question. Is, you know, hey, how do you all get started? What's a good product or a place to start? And really, the super wishy-washy answer is wherever your passions take you. You're definitely in the right spot. You have a whole bunch of people from all different backgrounds and specialties who are more than happy to help. In a few minutes, I'll direct you over to our Google Groups, which has a pretty lively set of discussions that, you know, you're certainly welcome to as well. But one of the kits that came up pretty early when we were powwowing is based on a UK standard microcontroller called a microbit. So a decade ago, the UK is like, we want to keep our kids smart. Let's fund a standard microcontroller board, and let's just give it to everyone from like K-12 or whatever the equivalent is. And so you can pick these up. Inflation brings this up to I think like 20 or 25 bucks now. But it's a complete board with a cable and a battery box and a programming interface that allow you to get started. And this is the definition of well supported. An entire nation has been developing curriculum and websites and YouTubes. And so this little board right here is the microbit. A bunch of us a few years ago bought a little extension for it called the Maqueen. And it's got all kinds of fun stuff on it. It's got an ultrasonic sensor to figure out how far away you are from something. The picture's not going to come up, so I won't do that. It's got LEDs you control, motors, you can drive it around, program it. Like, if you were coming at it from like a dead stop, I want to get involved, but I haven't done any of this yet, the Maqueen with the microbit, it'll set you back about 50 bucks. But between the massive amount of online information about it and all the hacks and stuff, starting from scratch, this is kind of where I gently nudge you towards as a first step. And then from there, the sky's the limit. We've all been there. We've all started out in different areas. Some of us are more interested in building hardware or designing hardware or programming. And it's literally just, you know, follow your passion. It's one of the last Renaissance hobbies. You're doing hardware, software, programming, planning, social implications, acceptability. Like, it's big, and this is why we're all here. We love solving problems and figuring stuff out. So this is actually what I would recommend personally to get your feet wet. Costs about 50 bucks, but you're gonna spend months going through and learning the ins and outs and all that.
Okay. The good thing with the microbit is that it's not like a single thing that only does one thing. There are a ton of things, like Alan said, that you can do with it. Everything, you can just use the little board. It has a little LED grid that acts like a little screen. You can just use that. You can have it react to, I don't know, shakes or whatever, make little faces. And then you plug the whole thing into the Maqueen, and then you got a little car that has a whole bunch of other things that you can, I mean, there is so much that you can do with it. And the programming with it, it's very simple. It's drag and drop, and then of course you can go and look at what those blocks mean in the code. And from that, the sky's the limit. You can do a whole bunch of things.
You can download sketches already, right?
Yeah, there's
sketches.
I mean,
Microsoft Make Code
it has a huge
tutorial
community behind it.
MicroPython. So you can learn Python.
Yep.
Yeah, you can.
Yeah, and there's and so if that's not where your passion lies, like if you've got access to a smartphone or a laptop, and you want to get more involved in programming, there's my nephew, I wish I remember the name of it, but basically you would use blocks as a programming language to program Minecraft characters, right? So if he was in the software side and you had access to a computer, that's another great place to start. Is it Scratch or Blockly?
Scratch is very popular.
Scratch, Minecraft? That's somewhere out there. So anyways, it's wherever, you know, your passion takes you. It's a lifetime hobby. And once you get into it, you're not getting out. It's gonna hold on to you for dear life.
Oh, now you're scaring me.
All right, so yeah, the Google Groups is a great place to start as well. We all hang out there. Most of us get notified every time there's a new post. And most of us are pretty friendly and we're all here to help. So you're definitely in the right spot.
Yeah, ask a question and you get a whole bunch of people like, oh yeah, you can try this, you can try that.
Yeah, I have GitHub with code for that as well, for the Maqueen and the microbit.
Okay.
Cause I did the LA little traffic simulator with, so you could do fun things with those.
Another actually good idea too is they have like I think Elegoo. Yeah. So you can buy like a $30-$40 kit, and what it has in it is it comes with an Arduino, which is like a little mini brain. It comes with ultrasonic sensors and maybe a servo and a whole bunch of LEDs and a whole bunch of things, and then online that comes with it, there's step-by-step tutorials. You know, plug this wire into this part, plug it into here, and look, now you're, you know, download this code into your Arduino. Look, your light blinks now. And so it just teaches you step by step how to do those things and makes it progressively more advanced, I guess, as it goes. But it's really cool because it shows you each of the little codes that you need for each of those things, and then you learn the shape of it and the function of it, and then you can add to it on your own once you learn the different things. So I learned a lot of that on my own from knowing nothing. So it's really cool. It's really helpful.
Okay.
And it's pretty inexpensive considering, you know, like $30 you can get a lot of little sensors that can do a lot of cool things.
Yeah, like it almost reminds me of like Minecraft with, you know, redstone in there. It's kind of like the circuitry of video games. You know, and they have like an observer that, like, you know, if something happens in front of it, then it will activate. Yeah. So that makes me think about these sensors. You know, if something's going to activate if something happens. So I feel like if I come with that same knowledge and come with that same like logical thinking of connectivity,
that's where all that Minecraft stuff came from actual hardware.
Yeah, from actual hardware. Yeah. You know, people have built computers inside of Minecraft.
Yeah.
I was like, and then ordered like had a phone in there, and then ordered pizza with a phone through Minecraft.
Wow.
Like I was like, oh my god. They went on the Pizza Hut like.
Oh wow.
App within the game, huh?
That's cool.
So yeah. Lots of places to start.
Okay.
So the second thing is, you know how like, I want to get to this thing, and then you're like, I don't want to do this whole thing, so I'll just pick it away in a corner, and before you know it, you're doing the whole thing. That's what happened this week.
The webpage?
With the website. Yeah. So there are nationally in the U.S. there's only 4 of the OG groups left that I can find, and there are a bunch of FIRST robotics and school-based and, you know, little things that are popping up. But as far as the OG ones, there's only 4 left. Homebrew, of course, is still with us. The Dallas folks are still alive and well. The Seattle Robotics Society. And then us, and we were all started in the 80s. I personally believe in my heart that the Robotics Society of Southern California started in the late 70s, but the truth of the matter is the Southern California Robotics Society went dormant for a couple of years, and then they regrouped in '89. So
89 is kind of the birth of the modern.
The new one, yeah. And our website has a bunch of information on it. But it was due for a little bit of an update. So it started out with a little bit of formatting change, and then followed by applying a theme. Ended up with me sitting with a half hour with one of our design students to kind of reimagine our branding and look and feel based on all the tools available on Weebly. And I would like to present to you our new homepage for the Robotics Society of Southern California.
I'm trying to bring it up on Web Archive, see what the old one looks to look like so that we can compare it, but it's taking forever to load up
Yeah, so Izzy, our design student, has been doing a great job of helping old part me to understand how the modern web works. And so there are a couple of basic elements that really make this new website resonate for me. First off, the picture and the banner on top. I have been holding on to this for years because this is like the soul of our club, is what we do. And this is a low resolution photo. I wouldn't look at it too hard because you will notice that I used an AI upscaler, which did a decent job of bringing out some of the detail. But I'm hopeful that Walter somewhere in his archives has the original one, and then I'll update in the background. So the three things I wanted to communicate for our club: who we are, why we're here, and what we're doing. So there's no information that was lost from the website. I actually have the original web page still in Weebly. It's just not visible. So yeah, we can always refer back to it and move information over. I temporarily set up an upcoming events on the right that Jim was kind enough to add, and I just shifted it up a little bit that we can use for upcoming events when needed. And this is really everything that as a website I would want to communicate on the homepage. Our two main ways of sharing information are through Google Groups, and we post all of our meetings on YouTube. So those are our two call to action buttons. I grabbed a bunch of pictures off of the homepage and turned it into a slideshow.
I like that.
Just to give a flavor of where we've been and what we celebrate about ourselves. And then we can't forget on the bottom of the page, we've got our Who We Are RSSC Robotics, the video that Jim painstakingly created for us that I think is just a great representation of who we are at our best. You're welcome to click and look around. Most of the pages have had the new branding applied to it. I did expand on the club officers page into a full page with a picture and a bit of a bio. Most of our officers have had a chance to give me something to put up. Ron, as soon as I spend a few minutes with you, we'll update your bio as well. Okay. But until then,
good with numbers.
Like really good with numbers. My mama always told me to make a friend. Jawas are misunderstood people, right? Let's have some.
Do it like that.
So we'll have some fun with it. It is my preference to leave Bob up as a board member for this year, just out of respect and to to celebrate his involvement in our club. And because the question already came up again, and I reserve the right to tweak things over the next couple of months. I like having a living website that focuses on who we are at the moment. But we always have a link to everything that came before us. So right now I'm calling it the archives. And a YouTube link by user, our meeting minutes from the original website, our meeting minutes from our newer website, our original RSSC website, which is still hosted on Walter's campus. So there's a bunch of information, articles, meeting minutes, and stuff there. And then the scanned newsletters from News Past. I think Jim Bubertsetsik donated these.
Yeah, those go way back to 89 probably. Or
Yep. August of '89 when the RSSC was reformed. I just put that in as a scripted document, just doodling around. The rest of them are over here. To again, back in the day before the internet, you would pay a membership fee, and we would create and then copy and then email out a newsletter because that's what you did back then.
I learned about it in '92.
The club?
Yep.
Wow.
I saw it on the penny saver.
Originally was like a mail, like snail mail, newsletter.
We would get it in the mail. Yeah. And it was exciting to see it every month.
What's interesting is looking back. I was just back at our kind of online records, and you're looking back, and a lot of this information is still stuff I don't really fully know. It's like there's a trove of information. Every project that was ever highlighted has this detail, and
Yes.
you're like, I don't know that, and, I mean, because there's so many rabbit holes in this thing, that they're all different. And some of that, even though it's old, it's still valid for basic electronics and you know, a lot of the,
Yeah,
you know, theory. So it's like, I still have more reading to do back in
Yeah, for
the
sure.
archives.
those archives have some.
Just from the past 10
really
years.
good tutorials on like just the basic like sensors, how they work, how to create one, and all that stuff. All the from scratch. I mean,
Very detailed.
It's a
Very
little hard
detailed.
to find, the only, the difficult part it's the kind of to catalog all that stuff and be able to find it, you know, easily, but, I don't know, maybe there is a search tool we have.
There might be, and the one promise that I'll make is I'll never delete anything. So, you know, these archives are important to us, so they'll always be available. Everything that I'm going to do as your social media guy is to arrange the information in a way to celebrate our identity and to explain in layman's terms what we are, right? So, yeah.
Is there a search function that you could use with this?
Let me look into that. There might be. And if there is, it would be for the pages hosted on this website. The search wouldn't extend to the archives that are stored on Walter's personal drive.
I think that one has a search in it too, because
That one might have a
search, I used it the other day.
Yeah, that one has a search.
But for this one, yeah, they might have one.
Yeah, I'll look into it. I'll look into it. There's a lot of more modern things that they've added in over the years. It's just a matter of finding them and.
Yeah, there's a lot of stuff, but some of us way deep.
Yeah, you have to know where to look.
Yeah, I don't know how I did, but back in the day, I found a tool that allowed me to download the old website that we had in its perfect format.
Oh,
That's
yeah.
how I did it. It was like a single track.
Your website.
And then I just dumped it in my, I have like a little space on the campus that they give everybody. And I just dumped it in.
Yeah, and I did that with in the archives of our Yahoo group. I captured the whole thing.
Yeah.
And was hosting that. I don't know if it's still hosting, I can't remember now, but
So the last thing I just want to bring up, and this will be an offline conversation with the officers, is back in 2016, we created a bunch of business cards with a QR code leading back to our site. To make it equitable, we ended up paying a lot more to get 4 different versions of the card, each card with a different person's project on it.
Oh, yeah.
So, there was the InMoov one, which was near and dear to me because I'm the InMoov guy. This was Eric's Walker. Remember Walker, Texas Ranger?
Oh, wow, you guys really don't know.
So Sergey's monster was one of them.
Oh, nice.
Track rover.
Yeah, that's right.
And then we had a Walter version with Walter's kid on it as well. So while I'm very proud of this design, and I believe it was the best design we had in 2016, Vistaprint is a very low cost. There is a premium to do it like this again, but I was just checking. To order 500 of a single card would be like $50. If we were to redo business cards, I would want to redesign them based on our more modern branding and identity, right? With more orange. We have a new logo at this time. I don't know if we would be able to get this ready in time for April, but I'm going to dig into it a little bit just to see what options are available. I like it, not necessarily because I think business cards are cool, but it's something that you can hand out that tells you tactily who we are. And with the QR code scannable on any modern smartphone, it'll bring them back home to our new identity on the internet.
Yeah, a single logo would be better. Whatever single logo we decide on.
Maybe not do the project thing anymore, but we could focus on a logo. And I think there's opportunities here. I can't commit right now to redesigning it and getting it ordered. So even if we're not able to do it in time for the Maker Faire this year, I think it's something that it would be worth revisiting in the future.
Yeah, for this year, I'll throw something together and just print it on my printer. I mean,
yeah,
one
yeah.
of our printers.
Yeah, so let's take a look in the cart right now. And I think we ordered like 1,000 cards in they lasted us 5 years.
I have one. I have one of those. Yeah.
Let's go ahead and remove that.
Of yours.
Yeah, so 500 cards, $51. 1,000 cards, probably 70, no, $80. So yeah, there's an economy of scale. 100 cards, you know, $33. So we've got options, and I would guess within 2 weeks or a week. But yeah, just another option we have, like to get our name out.
Yeah, we should probably do that. I mean, it's been a long time. 7 years.
Yeah, it's been a minute.
Yeah, I mean, now we have our new branding, our new logo. We can.
Yeah, it's an option. I'm sorry I can't commit to doing it right now, but I'll commit to looking at it a little bit more.
Sure.
And if anyone else has, like, I've got the design bug and I'm on my way around Inkscape or whatever, you're more than welcome to it as well, for sure. And they're cheap.
Yeah, that's to do the official ones. For the show, we could just do something to get it out there. I mean, it doesn't have to be.
Yeah, so
perfect.
Yeah, sorry, a little bit long. That's what I want to share with you today. Who's next?
Thomas, you're up.
Oh, goodness. Hold on. Who else is after me? Because I need a minute. I didn't know I'd be coming up right after him.
Okay, John, are you ready? Oh, did John leave? No, he's there.
Hey, John, are you with us, or did you step away for a minute? Just checking in. I see a foot.
I see movement.
Oh, John,
Your mic is muted.
Us too.
Oh, John, if you're talking to us, you're.
Oh, there's a button to ask to unmute.
John, you're muted.
He might be in the middle of something else too.
I can see a little movement there.
Sorry about that. Can you hear me now?
Yeah, we hear you.
Yeah.
Oh, great. Okay. This is just a demo to give you a rough idea of what it might look like. This will give you a really low bar to do better. But anyway, what happened to my, oh, I know what happened here. Yeah. Shoot. There we go. Okay. The rules are really simple. I've emailed a copy of the playing field to Jim and to Ben, and I assume somebody knows how to put it on the website. Also a text copy of the rules. And this is it. You make your robot or robot arm draw continuous straight lines connecting 3 arbitrarily located small circles on letter-sized sheets of paper. I'll run it now. Takes a second for the Lego to boot up. The idea is to draw a straight line from number 1, where you begin, to number 2, and then continue drawing the line to number 3. Okay, here we go.
Linear, actually.
I drew the line already and tapped the pen and lifted it up. just so I wouldn't draw another line and confuse the issues, but that's it. Now, lest you think it's too simple, I encourage you to just try it. I think you'll find that drawing a straight line is harder than it looks.
That is
Yeah.
true.
Well, it's doing anything straight with the robot is not as easy as it looks.
Especially as it's rotating, so that means the arm has to.
And the arm is,
Yeah, but CNC tools have to do that.
right. Now you were gonna send the rules again, right? Because it was corrupted. I couldn't open the.
I did, I sent it to you in a text file.
Okay.
Let me see, how do
So I
I,
can probably have that now. Yeah.
okay, I'm gonna do a share my screen and okay, it's this one.
All right. I don't even see it in the email.
There, now you should see it.
Yeah. I mean,
I don't know what's going on here, but all right, let's
I
get
see
this
what
out
it
of the.
says.
This is the one with the rules. I have to pull it down.
Maybe send the rules again to us, because yeah, I kind of don't. I just have an email from you that says I went to bed early. I'll send it tomorrow.
Okay, did you get an email after that?
Yeah, there's nothing after that.
I didn't attach it. Oh, well, okay, I'll send it to you again. Sorry about that.
No, that's all right. No.
Let me show you. Okay, how do we quit sharing the screen? Oh, new share.
Oh,
There we
it
go.
did.
Yeah, I have the email with the text file.
The rules file is attached. Mine blocked it. Unsafe. How is a text file unsafe? It's a
Yeah.
TXT.
Yeah, it's a TXT.
I should be happy my system is catching things, though, I guess.
You can see this screen with this window with the three
Yeah.
blue dots. Okay,
Okay, so we got the rules and we got the diagram.
yeah.
Okay, yeah, the PDF, I could add it onto the site, so
Yeah, yeah.
that's good. Yeah.
Whatever. Yeah, whoever gets to refer. I mean, I don't know. If you like to do it, then I'm not going to fight you. If you're motivated, the less work I have to do.
Yeah, we'll make sure it gets on the website. It's good.
It's a fight over our OCD. Oh, it's only the OCD talking there. I don't want to do work.
Thank you, John. Any
Okay,
questions?
Did we set a contest date or?
So that's the other thing is because
next
of are we going to be able to do? People still want to do this for April because we have a lot of we have the Maker Faire going on and we're prepping for that too.
So let me see.
And there's a guy, a coworker of mine. He wants to. He's interested in possibly competing or. So I'm going to forward him the info, but that's another person that might.
All right, cool.
So send it to. I don't know who else is.
In April, on the first Saturday, we have the Maker Faire, and then the next Saturday is our meeting. Do you guys want to push this one back by a month?
I'd be in favor of that.
Yeah. Yeah.
Okay, so let's move it up to May the 13th.
Yeah, I'm gonna get InMoov to do it.
Oh yeah, with his arm writing.
Sure. How hard could it be?
The Da Vinci tool. They did it in the 1600s, so you can do it. It was a mechanical device. Yeah, didn't have any intelligence. So.
All right, so it's set for May the 13th.
Sounds good.
All right, guys. Thank you, John. Any questions? If not, Thomas, you ready?
Yeah, can you hear me okay?
Yeah, we hear you.
So I'm going to tell you a little bit about, I'm working with GPT-3, which in case you don't know is the big brother of ChatGPT. It's the next level up by about 1,000 parameters or something. I think it's 6 billion versus 120 billion. I'm not sure of those numbers. You'd have to look those up. But anyway, so a lot of you know I work with ezrobot software, and one of the hardest things in working with this, because I want my GPT to be there for one reason, and that's to be a chat bot and chat with people. And so my robot sounds somewhat intelligent. And I've been going back and forth with the people at OpenAI and telling them what I need from it, and they pretty much are ignoring me. I guess roboticists are a small niche in their market, if any. I mean, okay, I've spent $30 or something for their services already. I don't have it free like Jim, because Jim's got the local model on his machine there. But then again,
I'm using the pay one too.
You're using them both? I didn't know that.
Yeah, I did the demo of both of them today, and the
Oh, sorry, Jim, I missed that.
The pay one's a lot better.
It is. But one of the hardest things about, and Jim may have touched this early this morning, so I apologize if I'm repeating Jim's some of what Jim covered.
Awesome.
One of the hardest things is the prompt. And Jim and I have been going back and forth on this a little bit. Jim, being that I didn't get to see your talk, in a nutshell, what did you cover?
Yeah, I covered basic prompt engineering and I mean, from what I've learned so far, and the prompt I made for Orange, which is based on one of those things I found with like just a formatted prompt with different sections like task, personality, dialogue, and that sort of thing. And then it seems it worked reasonably well, but there's a long ways to go.
No, I belong to a part of the HBRC group. They have a SIG, a special interest group called the Verbal IO SIG. And last Thursday, we were talking about using GPT and finding the best way to prompt it, like Jim was probably talking about. And Martin, the co-founder of the group, he showed us that, and I don't have the video because it's not up on YouTube yet, but he showed us that he could get his robot to emulate any personality just by the right prompt. And these GPTs are really geared towards being friendly, nice. Thank you very much. Oh, a robot is glad to serve you very much. Thank you. And it gets a little annoying. So Martin, because I suggested it, started playing around with it, and he found that he could just put in a phrase, and I'll show you a snippet of his code in just a second. Ross, were you there at the Big Sig? Not this Thursday? No. All right. So I'll show you a snippet of his code, and it's really interesting how little you need to do to break it out of that happy, oh, I'm here to serve you. How can I help you, master? That gets kind of old. So let me show you that clip. I don't want to misword what I'm going to say, and I haven't attempted his work yet, but I'm trying to duplicate what he's got. So let me share my screen. Just a second. And as a lot of us know, a lot of us want friendly robots. Not everybody, but I'm one of those people. And I'm sure Alan likes his robot to talk. Alan, how's your progress been on that?
Oh, I haven't touched the large language model stuff in a little while, but I had a pretty good integration between NVIDIA Riva and GPT-3 for conversational. Yeah, it was pretty cool.
Are you going to hook that up to Gray someday?
Probably, yeah. Gray's being pulled out of mothballs. He's gonna get a fresh coat of paint, and he's gonna be able to flirt with people with his winks and his blinking eyelids. And he's going to participate in the Connect the Dots in May. So yeah, yeah,
Well,
might
that
as well.
sounds really cool. Yeah, I want to see that. So I'm still let's see. Still trying to find the file. Just a second here. Okay. Oh, that's right. I did a snag it. That's where it is. Share screen, optimize for video, share, whoops, wrong screen, hold on. Sorry, guys, do that too often. Okay, you see the screen with the code?
Yep.
Okay, so.
You might want to enlarge it if you can.
Yeah, let me see what I can do here. So right around, I got the right screen. Some of the things he adds are something like, "You are a very depressed and sarcastic robot."
That's what I want. Oh, that's what I was gonna do. Marvin, the paranoid android, right?
Basically, you basically tell GPT what to be, and
Yeah.
here's a little bit more. So this is part of his description, that part of the prompt anyway, and he has a verbosity level, a state level, unsarcastic, slightly sarcastic, sarcastic, and he feeds these into his prompts. And I don't have his full set of code, so I can't give you much more than that.
Is this his? That's his code. He's kind of written his own prompt maker, huh?
Yeah, yeah. And he's integrating it into his GUI here, where he can set how much he talks versus listens, its humor level, its contribution to the thing, its curiosity level, et cetera, et cetera.
Sliders like this on. This is Westworld, Thomas.
We can only hope.
They had sliders like that. Yeah.
I couldn't stomach Westworld. It was too bloody. So
no, it was too bloody. Yeah.
Oh, here it is. So this is what it really came down to. Get pattern. Pattern is respond to input, verbosity, as if you are a blank robot.
Oh, okay.
So, it seems really difficult until we start doing it, and then it seems like, oh, well, this just makes sense. And one of the things I found about GPT is when you want to know how to write a prompt for GPT, one of the most important people to ask is GPT.
Oh, didn't think of that.
You don't think of this. This thing knows how to query itself. And sometimes you get a good answer and sometimes you don't. Now, one of the things I've really liked about it, and I'll show you this, I'm not sure if I showed you, I've showed so many people, I can't remember who I've showed this stuff to. So if it's a repeat of what you've seen, just smile and say, Tom's at it again. Thomas just doesn't know what he's talking about. Anyway, so what it does is it has AI hallucinations. You've heard that before? No?
Yeah.
Yeah. It fills in the blanks. It makes up stuff it doesn't know. And that's really bad when you're trying to get a statistic. How much did it rain last month? Or how many people in Santa Fe like cheese burritos or something. Right. But it's really good when you're saying, well, tell me about your brother. Oh, I have a brother. Where does he live? He lives in New York. How old is he? He's 42. He works at McDonald's. It makes this stuff up on the fly. And I wrote to OpenAI. I told them about that. Or they say, oh, we're going to fix that. I said, fix it? No, don't fix it. I don't want you to fix that. I need that. And
that's fictional. You could use it to write a novel, right?
Yeah, you could. You really
Movie
could.
script.
So
Getting at one.
that's one thing I wanted to show you
Yeah,
is
that's what I mean.
Martin's work.
That's what I meant. Yeah.
Martin's work is very, very interesting for that.
I've seen videos that people have done that.
Because it knows how to format it and everything.
Yeah, and a couple of things we were talking about is, well, if it can format and sentences so properly, why can't we or somebody else program it to pick up a box based on looking at videos of picking up boxes? And I think I talked about this with you, Jim. Didn't we have that conversation?
Yeah, maybe a little bit about trying to get a robot to do something, right? But
yeah, just by looking at the action. And you say, well, how does it know what's happening in the action? Well, we all have this, we all have this AI software now on the Oak D cameras and such that can tell where people are looking, where their body is positioned, where their hands are in 3D space. It has so much data from a photo or a video that it knows what's going on. And if you can translate that to a robot's servos and arms in motion and such, it wouldn't be a long stretch. And it'd certainly be a shorter stretch than getting it to converse in perfect American English. So that I've been thinking about and looking for a mathematician to help me with the math on that. Anyway, that's one other thing I was looking at. A third thing is, well, the GPT here, and I've got it all connected. So this is my chatbot for Betty 9. I think I showed this. I know I showed it to somebody. I can't remember whether it's your group, this group, or the other group, or the third group I'm with. I think I belong to too many robot clubs.
Can't help you there.
So for those of you who missed that presentation, here it is in a nutshell. This is ARC, the something autonomous robot software, or I forget what it stands for. Anyway, it's part of the Easy Robot package. Yeah, you got to pay for it. Yeah, it's expensive. Well, not too expensive. It's $100 and change a month. But it gives you everything in one spot. It lets you hook everything together and operate it from one place. It's kind of like Ross for idiots. So there you go. The personality I hold in a file, a personality file or a persona file. I don't know. You tell me what you like better. And I have it right on my C drive. Can you see that screen? Am I still sharing that?
Yes.
Yeah, yes, you're fine.
Okay. So here, Betty 9 data. And here's the character template. Oh, that's the wrong one. Here's the character template. And that just opened on another screen. Just a second. So I showed this to Jim, and Jim has seen this, and some of you also have seen this, where I'm feeding in each part of the personality one line at a time. And GPT gets it. It gets it right away, and it's going to recite these things if asked. What's your favorite band? What's your favorite animal? And one of the interesting things I did the other night was I said, what's your favorite band? And she says, the Beatles. I said, what's your favorite Beatles song? And she says, Help. I said, what's the first line of that Help song? And she repeated it word for word. So this is all I seeded it with. So
it took off from there.
And it took off right from there. And we can duplicate that. And we can try to duplicate that right now. We can do that again and see if it works. Like, and I asked it another time, I asked it, do you have a dog? Oh, yes, she has a dog. Or what is the dog's breed? And on and on and on. And it just digs in. And again, it makes it up all on the fly. And unless you're saving it, if you're saving it, she'll be able to remember what she said last time. But as what, Tim?
So you can re-download this file back in, and next time you run it, and it remembers all this stuff.
Yeah, and the next step after this is then summarizing each additional conversation and then saving that as part of this. So then it has a history, a memory of the past. And that's the next step I'm working on with this. And this is a large number of characters. And of course it gets fed in and then it feeds it back and forth each time, which adds up. Yeah, it was only $1, but if you got $1 a day for 30 days, it starts adding up. If it's $2 a day for 30 days, then you're really, and it adds up even faster, obviously. So another problem with GPT is it's not live on the internet. It doesn't know what time it is. It doesn't know what day it is. So you have to specify that. And I do. I give it a timestamp. So the first thing I would do is seed the personality like this, and you can see it's all there. And if I want to check, I look at the OpenAI chatbot skill, as they call them. And it's all there. And you start the conversation. Hello, how are you? I'm doing great. We could probably just change that on the fly here because Arc is adding that for me. Make sure I did this. Betty 9. So if Tim, could you mute your microphone because it picks up everybody's sound at this point. And
sorry about that.
If everyone could just please mute for a few minutes here, just want to give a brief demonstration. Hello there.
I'm sorry. What are you
How are
saying?
you?
I am doing well. Thank you for
Are you
asking.
hearing the voice replied? Would somebody answer, please? Tim, can you hear it?
Oh, you hear it fine, Thomas.
You hear her as well as me?
She's a little bit low, but I can hear her, no problem.
Yeah, I'm not sure how to turn that up because, like I said before, it's all in one system. Try turning up my sound.
Oh no, it's fine, Thomas. We can hear her.
All right. So so we're gonna try that. Do you like pets?
I love animals, especially
Do you have any
puppies and
pets?
kittens. I love animals, especially puppies and kittens.
Yes. Do you have pets?
I have 2 dogs and 2 cats.
What are your dogs' names?
I have 2 dogs, a golden retriever named Simon and a German shepherd named Mia.
Tell me about your golden shepherd.
I am thinking about Simon, my golden retriever. He is a very friendly dog who loves to play fetch. He is also very obedient and listens
Obviously,
well.
I said the name wrong, but she corrected it, and the speech recognition got my input wrong, but still she was good with it. She's never had, I have no text in there about dog named Simon, who's a golden retriever. So let's follow this a little bit longer.
So she's making all this up?
Yeah. Okay, I'm gonna ask a few more things and I'll stop. When did you get Simon?
I'm sorry.
When
What
did
are
you get
saying?
Simon?
I last saw Simon yesterday afternoon when we went for a walk around the block. He was his usual happy self, wagging his tail and jumping up to lick my face.
Again, the speech recognition is not picking this all up. It's probably because I got noise in the background. Let me shut off my heater here. As Jim will agree, voice recognition is still not perfect. It's getting better, but still not perfect. How old was Simon when you got him?
I am not sure how old Simon was when we got him, but he was a puppy. He is now
Was he
2
easy
years
to
old.
train? Was he easy to train?
I'm sorry.
Was
what are
he
you
easy
saying?
to train?
I am not sure what you mean by easy. Simon was a very obedient dog and listened well to commands. He was also easy to potty train.
Okay, that's all I'm going to do on that. Anyway, you can see it's just making it up. And even if the speech recognition isn't getting it right, she's guessing at it and replying fairly well.
Hey, Thomas, what type of speech recognition are you using there? Is that the one that's built into the ARC?
Nope, that's Bing. Well, it's built in, but it's not. It's not. It's a service. It's a web service. Bing Speech. You get most of it for free. If you go over a certain limit, you got to pay them. The speech synthesis software that I bought years ago for $40. That's a special voice I put on this.
I've been playing with a speech recognition AI called Whisper, and from what I've from my experience, it's been working really good. You might want to look into that, perhaps.
Is that a local one?
Yeah, it can run locally. It's made by OpenAI, same guys who make ChatGPT.
Oh, that's interesting. Yeah, I'd love to have something local because you can't always count on an internet connection. All right, one other thing I want to show you is I've been trying to replicate this whole ARC software thing in Python. And this is just the beginnings of it. This is using Google Speech this time. And the local voice that I downloaded, and GPT-3 with my account I have, and it works. I've managed to improve it all along as I go on. And again, like the other software, I'm trying to get this to have some sort of a memory as well. Anyway, that's about all I have to show. Any questions before we move on?
Any thoughts on how you're going to implement the memory? I've been kind of working on something similar, implementing memory for large language models. I have some ideas kind of bouncing around in my head, but I haven't actually implemented anything. I was just curious if perhaps you have any thoughts on that.
Oh yeah, I've got it all planned out up here. I just have to put it into code. What I'm going to do is every line will have a timestamp and it'll be saved off to a file. And when I'm all done for the day, I will take that whole file, upload it to GPT, let GPT summarize it, and load it back onto my local machine, and then feed that in as part of the prompt. That will work. There's no reason why it won't.
I thought about something like that with generating summaries, using a large language model to generate summaries. And I think you're right. I think it will work, but I think there's the chance of perhaps losing some, as more of the conversation is summarized, you may, don't you think you might lose some of the nuance or some of the details of the conversation, perhaps like things that happened a long time ago?
You will lose it, but I want my robot to emulate a human, and humans forget. And that's okay. If she can't remember what she did 3 months ago, I'm good with that. But if she can remember yesterday that she talked to me about, the price of tea in China, great. If she says, if I ask her, what did she do 3 weeks ago? And she says, I have a vague recollection of talking to you about the C language, even better. And if I say, well, what did we talk about then? And she says to me, I really don't remember, I'm good, because that's very human. Anything else, or we're done? All right, thanks, guys.
Sorry about, there you go.
I said, we were talking about this earlier, because I was answering the same question to Gene about, I haven't had any plan, I haven't got that far yet, but my plan was just to allow the dialogue to scroll off once I run out of, if it's 4K of data and my prompt is only 1K, there's still 3K of conversation, and that's a lot. And then, but rather than let it completely just scroll off, summarizing, I'd like to hear these ideas. Summarizing sounds like a great idea, and that we could all use. Like, you summarize 10 lines into 1 line. Tell GPT to give me 1-line summary of the conversation we had on Tuesday or every day. So then it's a little bit slower. Or you could even have it do it like, give me a 5-line summary of the one we had yesterday, a 3-line one of the one last week, and a 1-line of the last month. So you have it tiered, and so and then it kind of gradually fades away. Does that sound good?
Oh yeah, that's good. That's really good.
Unfortunately,
I think that's
deep learning models don't do that very well. I mean, you got to move to like a Markov model to be able to do that.
To execute it, or
yeah, the current deep learning neural net models will not be able to do that.
Or which part won't they be able to do? I mean, I can tell.
They can't reweight new inputs without a complete retraining phase.
But we're just talking about. We're talking
about prompting.
Just the prompt, which is, I don't know how, you'll have to explain to me how prompts work really, but the prompt seems to be like, you can train by prompt, essentially. They call it prompt training.
One shot.
Zero shot or whatever it is. So, and this is very powerful, using a prompt you can give, like, you saw what I did. I gave a bunch of facts. He gave a bunch of facts. The model repeats those facts back and even can answer semantically anything about that, and pretty well.
You can have the model itself generate its own summaries. And then rewrite its own prompt.
Exactly.
Yeah. Well, that's just a fancy add-on. You could rewrite it yourself manually if you wanted to before you get to that. But yeah, automating it would be ideal.
Pretty easy,
yeah. I think that's a great idea.
One idea I had that I'm kind of working on right now is along with the summary, which I think is a great idea. I was kind of doing what Thomas was mentioning, storing all the historical prompts in some type of database. And then when the user prompts something, what I'm thinking about doing is searching through the database to see if there is some type of match and pulling up those old prompts. So if, for example, the user asks maybe 3-4 months ago, do you have a dog? And then the AI responds, yes, I have a dog named Sandy. 3 months later, if the user asks a similar question, what's the name of your dog again? It would be able to search through that database, pull up the prompt or pull up the answer that the AI gave, and then feed that into the input prompt. So that was kind of my idea.
That's one. I guess that's all good. If that's your goal, like my goal would be write it. I want to write the personality myself, all of it, and put it into the archive eventually as it grows. If it grows, and then everything that I want in the thing always comes out. Like it only has a dog named whatever. That's it, and it never adds any new ones. But it can, you know, it can add a new opinion here and there if you, in other words, you get to control the box that this thing is in and how much it can go outside the box. That's not just remembering the things it made up. To me, that's like, okay, that's good for fiction, you know, but not if you're the fiction writer. What if you're the writer here? or you're the writer of facts. You want to, you know, you have a robot. It has a physical body. It's got sensors. It's got all this stuff that's real life, and you want only that reality in the system. So that's the challenge I'm facing.
All right. Any other questions?
Fair enough, Jim. But you kind of like to. It'd be nice to have a switch to turn that that hallucination on and off, and to the point where it said, "Well, you know, I don't have anything on what happened last week," instead of making it up on the fly.
Yeah, I mean, making up stuff is cool. That's or like I'd like to just be able to control where it gets to do that. You know.
Yeah.
Especially with opinions. Like my robot, I have no idea what its opinion is on everything. So I'll let ChatGPT decide, I guess. But for what parts on its body, that's fact. That's real. It can't make it up. You know, so some things I'm okay with making up, others not. And that's where it gets tricky. You want to make sure it sticks to those areas, you know.
Well, I found out if you state something, Jim, it's going to stick with it as long as it's stated in the conversation, and you're sending the whole conversation back to GPT.
Right. But yeah, the database thing is seems like a good idea to extend. Essentially, you're extending the prompt into the past at an arbitrary length, I guess. But then you'll have to write SQL queries or no SQL or something like that. Well, that could be a way.
Yeah, or sometimes search, right?
Or you just use a flat file like I did.
Oh, to do a query or grep?
No, just once I feed in all that information, it doesn't have to search. It doesn't do a search for it because I don't have to do a search for it. It's searching it inside of that prompt that's going back and forth. The whole.
No, I'm talking about what Gene's idea was, have an offline prompt.
An offline
database that's much bigger than 4K. You know.
Well, that could be done too.
Yeah, and then you basically query the offline database and then insert into the prompt what you found. Right? Is that the idea?
Yeah, that's the idea. Some type of semantic search. So it would be related to the current input prompt that the user is typing right now. So, for example, the user and the AI is discussing dogs, and maybe you had a discussion about dogs a month ago. It would pull up hopefully the relevant parts of that discussion so that it would feed that back into the input prompt.
And also, it's a matter of deciding, do you want your robot more like Data from Star Trek, where he remembers everything, or do you want it more like a human who forgets half of everything after 2 or 3 weeks?
Yeah, that's a good question. But yeah, I kind of forgot you can use ChatGPT to then do you could say, well, you could run you use ChatGPT itself to do the database query, right? You could say, well, I guess you'd have to take it in 4K chunks, but you could like feed the first 4K of the database into ChatGPT and say, is there anything about dogs in here? And then the next 4K and the next 4K until you collect all of whatever's there. So you don't have to write a traditional database query. That would be cool, huh?
Yeah.
And at the risk of going off topic, I also heard that GPT-4 is coming out next week, which is supposed to be multimodal.
Oh, yes. I heard about that with visual, pictures, text, and audio, right? Everything.
What I heard,
that should be really fun.
Is it multimodal means that, right? The pictures.
Yeah, with pictures, audio, text. So maybe
Everything.
that your robot to describe what it's seen.
Yeah, I was gonna try to download, a whole separate model for scene description and try to fit that in my GPU and then run it separately. But if, I may still do that because GPT-4, I don't know when it's coming out for real, but when that comes out, I'll definitely try the visual part.
Yeah, how are we going to get our robots to dream if they can't see and remember what they saw,
Yeah, but I mean, yeah,
The
there's
goal, robots dreaming?
Well, I saw some really interesting. I saw some really interesting work where people combined models, like you just mentioned, Jim, where they were combining, for example, on the back end for text. They were using GPT-3, and then they were also using like a CLIP or a BLIP2 model to do image processing, which would take an image, convert it to a textual description, and then they would pass that into GPT. I thought that was really interesting.
Well, that is cool. Yeah, that's kind of on along the lines I'm interested.
Well, since we're still in show and tell, I do have a couple more things to show and tell. Like we're little kids at school here. Again, this is my Latte Panda. I finally got it in the case while we were talking.
Oh yeah, I got one of those cases.
Yeah. Warning. It gives you these 2 wires for antennas, and they're really hard to install.
Those things.
What's
That's
that?
hard. Yeah.
I got the Wi-Fi antenna installed, but I can't get the Bluetooth. I think I crushed the terminal because I didn't know how to do it. And they're very, very, very tiny, little tiny millimeter size terminal.
Yeah, it's like a punch-on. It's a snap-on coaxial or whatever you call it.
Yeah, and I think I'm going to have to return the board because I think I crushed it.
UFL terminal. Yeah, that is a problem. Yeah.
I may have to return the thing, which is too bad because I just got it. One nice thing about these is supposedly there's an Arduino in there somewhere.
Yes, I use the Arduino too.
And you have all these, unlike a regular computer, you have all these terminals you can connect to. Like I don't know what the specs are. I'll have to read them.
So for those of us who don't know, or some people haven't really seen the Latte Panda, it's a single board computer that it can run Windows or Linux. Costs about $200, $250 for the Windows one, I think, with a Windows license. And I use it. It's right here in my robot. It's up here. You're looking at it. It is the 4 gigabytes, I think, and they have a new one. This is the Delta, the Latte Panda Delta. They have Latte Panda Alpha, Delta, and a new one, the Delta 2. And it is it's got a built 3 or 3. Which one did you get, Thomas?
Delta 3.
So I have the Delta 2, I think, or no, mine might be the original Delta.
And if you're crying about the price of the Raspberry Pis, you'll cry even more about these.
Well, I'm sure it's a lot more powerful than a Pi, right?
It's a bit more powerful. I don't know how much. It's not.
It's not a lot more powerful. It's a bit more powerful.
Pi 4.
Pi 4, I think it's more powerful.
Okay, so
because it's Intel. It's an Intel.
Thomas, are you done with your show and tell?
Oh, last thing, I got a new watch. I want to show off my new watch.
Oh, okay.
Wait.
It has well, tubes on it, and you see they light up.
Oh.
I mean, every watch needs to have vacuum tubes, right?
That's very steampunk.
Yeah, that's all. I'm done.
All right, Thomas, thank you very much. That was the last show and tell. So I think we can call it a meeting for today. Didn't want to stop the recording. Thank you, everybody, for joining us, and we'll see you next month.